Hi grade 11s and welcome to this video. In this video we're going to be working on the Maths paper 2 for June 2023, and this is a Gauteng province paper, so it's a provincial paper. So the paper is 2 hours and it is for 100 marks. So as usual we have our instructions and then we move on to the first question, which is on statistics. Okay, so question 1 says, the following box and whisker plot and accompanying 5-number summary shows the marks obtained by grade 11A for a mathematics test out of 50. Okay, so this is the 5-number summary for grade 11A. As you can see, they gave you the minimum, Q1, Q2, Q3, and the maximum. Okay, so the highest mark that anybody got in that class, or some people got in that class, was 45. Okay, so then they tell us that the following data shows the marks obtained by the learners in another class for grade 11B for the same mathematics test out of 50. So as you can see, they gave us another data set. This one, they've already completed it for us. Okay, so the first question, 1.1 says, determine the 5-number summary for grade 11B. Okay, so the 5-number summary for grade 11B, we're going to find the minimum of it, Q1, Q2, Q3, and the maximum. Okay, let's start. So with the minimum, it's quite simple. You just have to take the lowest number in the data set. But first of all, you need to make sure that your data is in ascending order. And if you look at this data set, you can see that, yes, it is in ascending order. So the minimum value is 10. And then you can also just speak about the maximum. Let's also just say, and we know the maximum, the highest is 48. So here is now how we're going to find the Q1 and the Q2 and Q3. So I would suggest that you first find Q2 because it's much easier. So when you want to find Q2, there are two ways. You can use a formula, but in this case, the data that we have is countable. Let me just show you how to use a formula to find it. So first of all, to find Q2, specifically the position of Q2, you're going to take the number of data points that you have, which I'll call n. You add that to 1 and you say divided by 2. So if you count the amount of numbers that you have here, you'll notice that you have 16 numbers. So that's 16 plus 1 over 2, which is 17 over 2. And that would be 8.5. Okay, because 16 divided by 2 is 8, so 0.5. So what that would mean is that your number, your median, your Q2, is between the 8th and the 9th number. It's in between them. So this is how we'll find it. We'll just say 1, 2, 3, 4, 5, 6, 7. This is 8 and this is 9. Means that it's in between here. So it's neither 29 nor 31. It's in between 29 and 31. So how you would find that is you would say Q2, to find Q2, you're going to go ahead and take your 29 and add it to your 31 and divide it by 2. Okay, and that will just give you 30. So there. So that's how you can find that. Now, you use that formula if you have a data set that is big, like more numbers than what we have right now. In this kind of situation, you really don't have to do that. This is what you can do. You can use the cancel method. So you take your pencil and then you're going to just cancel 1 and 1 and 2 and 2 and 3 and 3 until you get to the middle. Okay. And as you see, when we do that, we get to the middle. That is indeed our middle. And so you would take the number in between them. So we know that Q2 is 30. Okay, so that's how we find Q2. And then to find Q1, let me just move this down. To find Q1, Q1 is actually the middle of half of your data set. So this is how half of your data set is going to be measured. You see, you're going to measure from 10 all the way to 29 because 29 is not Q2. Okay, you use 29 to find Q2, but it's not Q2. So this is half of your data set. This is your lower half, and you just find the middle of this. Again, you can cancel. So cancel and cancel, cancel and cancel and cancel until you get to the middle. So these two numbers are right in the middle. So you're going to add them and divide by 2 to get that middle. So Q1 is equal to 21 plus 21 divided by 2, which is just going to give you 21. So there, our Q1 is 21. And then to find Q3, it's actually the same thing that you're going to do here. You're going to look at your upper half. since this is the middle, the upper half starts from 30 all the way to 48, and you're going to find the middle of that. So cancel and cancel and cancel until you get to the middle. And you see that 38 and 42 is our middle. Then you're going to say 38 plus 42. So this is to find Q3. You're going to just say 38 plus 42 and then divide by 2, which will give you 40. So that is our Q3, right? Q3 is 40. And that's how we find our 5-number summary. Okay, so there we go. That is the first question, to find the 5-number summary. And then we move on to the next question. The next question 1.2 says, on the diagram sheet provided in answer sheet A, draw a box and whisker plot for the marks for grade 11B. Okay, so we're drawing a box and whisker for them, grade 11B, because this was already grade 11A, that was completed. So we have our data. Okay, so our minimum, since we're using that, okay, we might as well just, this is what they gave us to use. Our minimum is 10, so that's where we put our whisker. So 10, right? Just right there. And then our 21, that's Q1. So there at 21, you're going to put a line down. But as you can see, this says 20. So you can let them know that it's 21 by writing the number 21 over there. You can write it on top if you want as well, but I like leaving it on the number line. So there. And then I need to also find Q2. Q2 is 30. So 30, yes, we have a 30. So we're going to put a line down for 30. And then we need to put for Q3. So Q3 is 40 that we have there. So we're going to put a line down for 40. And then lastly, our maximum. Our maximum, I think that was 48. So 48 is our maximum, yes. And so we put that, that's kind of like in between the 45 and the 50. So here's our 48, we put that there. And that is a whisker. So then write 48 since there is no number written there for it. Then we're going to just join our box plot. So we're going to join by joining the quartiles first, Q1, Q2, and Q3, join that. And then Q1, Q2, and Q3, form a box, and then just connect the whiskers like that. It is also called a box plot. So that is 48. Okay, so there we go. That is the box plot or the box and whisker diagram. Then we move on to 1.3. And it says, calculate the mean mark of the grade 11B. Okay, so calculating the mean mark, we need the data set. So we're going to use this data set and calculate the mean mark. Okay, so here are our values. So what you're going to do to calculate the mean, you're going to add all the numbers up together and then divide by the number of values you have. Okay, so I'm going to add the numbers up together and get that number there first. And when I add everything up, I get 480. And then I'm going to divide by the amount of numbers that we have. And we have 16 values, so divided by 16. Okay, so there's 16 learners because of each of their marks. So the average of the class is 30 out of 50. Okay, so that is our answer there. And then we move on to the next question. So 1.4 says, calculate the standard deviation of grade 11B. Okay, so we have our data and we have to calculate the standard deviation. We're going to need a calculator for this. So on your calculator, what you're going to do is you can go ahead and press mode first. And then you're going to go for the option that says stat. Yours is probably going to be number 2. Mine is number 3. But you go for stat. And then you're going to choose option 1, which says 1 VAR for one variable. So this is a one variable data set that we have. So you're going to fill in all your numbers here. So all the way from 10 to 48. And you need to make sure that you end at 16. Like the number 16 should be here so that you know, okay, I do have 16 values for real. Okay. Okay, and you'll notice that you have 16 numbers. So after doing that, you're going to go ahead and press AC and then Shift and 1. And then you can go to option 4, right? And then you see that option 3 is telling you about your standard deviation. Option 1 is the frequency, the amount of values you have. Option 2 is the mean, and then standard deviation. Okay, so that is that with this. So it's really just the standard deviation of your X values, but I'm just going to call it the standard deviation here. So we're finding the standard deviation. So press 3 is equal to, and you see that we have 11.43. 11.46. Okay, so that is our standard deviation, 11.46 marks that we have there. Okay, moving on to the next question. 1.5 says, how many learners in grade 11 obtained a mark that is higher than one standard deviation above the mean? Okay, so here is what they mean by that. So we have to break it down like this. We want to find out how many learners got a mark higher, right, than one standard deviation above the mean. So we'll talk about this higher soon. Let's understand what exactly one standard deviation above the mean is. Okay, so it means that you have your mean and you're going to go a standard deviation higher than the mean. Okay, so since you're going one standard deviation higher than the mean, you're really taking the mean and you're adding a standard deviation to it. If you wanted to go a standard deviation lower than the mean, you take the mean and you minus a standard deviation because you want to go from the mean and you want to go a standard deviation below the mean. Okay, so that will be mean minus standard deviation. But since they said one standard deviation above the mean, we're going to take the mean plus the standard deviation. And so what they want you to tell them is how many learners in grade 11 obtained a mark that was higher than one standard deviation above the mean. Now that you know this is one standard deviation above the mean, you need to count the marks that are higher than this value, one standard deviation above the mean. Okay, so we already have this here. Let's just calculate what this is going to be. So our mean was 30 and our standard deviation was that 11.46. So 11.46, which is quite low. Okay, so here's also another thing about a low standard deviation. It's kind of like your mean is here. If you have a low standard deviation, it means that your other data points were more consistent. So in this context, in this situation where we're looking at the marks of learners, it really just means that that mean mark of 30, right? We had a lot of learners that were getting marks that were close to this. The data was more consistent. That's what happens when you have a low standard deviation. And you can really just compare your standard deviation to your mean. Okay, it depends on whether the standard deviation is equal to or greater than your mean. Okay, or if the standard deviation is lower than your mean. So if your standard deviation is lower than your mean, that is a small standard deviation. And it just really means that your values or your data points are closer to your mean. Okay, they're not that far from the mean. So there was more consistency. Okay, so when we calculate this, 30 plus 11 is 41. So that is 41.46 that we're going to have there, right? So since we have 41.46, we're really just trying to find out how many learners got a mark higher than this number. So let's look at that. Let's just count how many learners got a higher number than this. Well, the good thing right now is that this is already in ascending order. So we know that this one is definitely not higher. You can just go all the way to a number that is close to this. The closest number will be 38. And you can see, compare 38 and that. 38 is not higher than that. Okay, neither is 37, neither is any of this. So it means that the numbers higher than one standard deviation above the mean will be these ones here. So that is 1, 2, 3, 4. So you can just answer them according to how they ask you the question. The question was how many learners in grade 11B obtained a mark that is higher than one standard deviation above the mean. So your answer can just be, that is 4 learners. And that would be our answer. Okay, so that is it for 1.5. Then we move on to 1.6. Okay, so 1.6 says, taking the interquartile range of the two grades into account, comment on the performance of grade 11A and grade 11B. So IQR. Okay, so let's just separate it. We're going to find for grade 11A. Let's see their IQR. So IQR, you calculate the IQR by saying Q3 minus Q1. And a little story about the IQR. You see the IQR of a data set. It's the interquartile range, right? So it's a type of range. If you think about the range of a data set, the range is calculated simply by taking the highest, which is maximum, minus the lowest. And I think this is a really good example that they're using because they're using the performance of students in a math test, right? So the fact that they're using something like that, we can think about it like this. In a class, you may get a student that gets a really high mark. And then you may get a student gets a really low mark. If you judged the class performance based on just these two, that maximum and that minimum, you're going to get very deceptive kind of data and results, okay? And you're going to make funny decisions based on that. So that's why the range is not a very good indicator for the performance of a class. That's why we use things like the IQR, because it goes more into where most of the people's marks would have been. And then it judges based on that. Okay, so let's go ahead and find that. So for grade 11A, they already gave us the box and whisker diagram for them. So as you can see, this is their minimum Q1, Q2, and Q3 that they have there. And they also put it down. So Q3 minus Q1, that is 30 minus 11. Okay, so that's the number that we're going to have there. 30 minus 11, which gives you 19. Okay, so IQR for grade 11A is 19. Let's find for grade 11B. So grade 11B, their IQR, well, we found their Q3 and their Q1 as well. So their Q3, as you can see, we marked it, that was 40. So Q3, Q2, Q1. So that's 40 minus 21. So 40 minus 21, that's also 19. So IQR is equal to, so Q3 again minus Q1, which is 40 minus 21, which is 19. Okay, so they have the same IQR. The IQR is not different. What was the question? The question was, taking the interquartile range of the two grades into account, comment on the performance of grade 11A and grade 11B. Okay, so because the IQR is exactly the same, the IQR is not really going to tell you how well they did, as you can see, because you can even get a situation where the IQR is the same. So all this would really tell you is that the consistency in both classes was the same. But it doesn't really tell you that, one class performed better than the other. We would have to look at things like, as you can see, the way this one looks and the way that one looks. I think I'm just going to put the numbers here so I can just properly compare them. We know that Q1 here is this 11, 21, and 30. Okay, so I'm just going to put that there. 11, we have 21 and 30. So now we can actually compare them properly. You see, when you're looking at grade 11A and grade 11B, a very good indicator for the performance of a class or any result would be the median. This is the marker for half of what the class got. And one of the reasons why the median is a strong indicator for the performance would be because it is not like the mean. Well, the mean is a good performance, but the thing about the mean is that the mean is affected a lot by outliers. And with outliers, I kind of briefly showed you what that's like when I was saying, what if we were trying to use the range to determine the performance? You see, the range is not a very good indicator for the performance because you could get a situation where one learner gets a really low mark and then one gets a really high mark. And then you can't really judge the class's performance based on those two because they could be outliers. Okay, it's just really low and really high, and then everybody else is like, yeah. Okay, and they're just like far away from them. And that's why the mean, though it is a good indicator for performance generally, but it will depend on whether you have outliers or not. One variable that would not be affected by outliers would be the median. And that's why it's a good indicator for the performance. So we can actually compare the medians rather. Now we can also tell them that the IQR is not a good measure of performance. However, it does measure the consistency because it means from the Q3, from 75% of the learners to 25% of the learner, there was a 19 marks gap between them, and it was the same in grade 11B as well. So the consistency was the same, but the marks and the performance are not the same. So based on the median, which class did better? It would be grade 11B. Grade 11B did better in that case. So we can see which class did better based on the mean. So this is what I'm going to say for this. This is going to be my conclusion. So let me go ahead and tell them that, first of all, we noticed that the IQR are the same. They're both 19. And then also let them know that IQR is not a good indicator for the performance of a class. However, it does show us that the consistency between both classes was the same. And then lastly, tell them that the grade 11B actually did better because their median was 30, while grade 11A's median was 21. Okay, so I just said the IQR of both grade 11A and B was 19, which shows the consistency between the two grades was the same. The IQR is not a good indicator to use to judge which class performed better. However, grade 11B had a higher median than grade 11A, which indicates that they performed better. Okay, so that is it for 1.6. And then we move on to 1.7, which is the last question in question 1. And it says, determine the percentage of learners in grade 11A who achieved less than 30 for the test. Okay, so they just want the percentage of learners in that grade 11A who achieved less than 30 for that test. Okay, let's look at grade 11A's box and whisker plot. So grade 11A, do you see that at 30, right? That's where Q3 is. Everybody who got either 30 or less than 30 would be here at Q3. So they want the percentage of learners, right? Okay, so the box and whisker diagram is like, it's a box, right? And it divided into 4 sections. That's why at Q1, we actually have, so think about it as a fraction. We have a quarter of our data set. As a percentage, that would be 25%. At Q2, we have half of our data set, which is 50%. And at Q3, we have 3/4 of our data set, which is 75%. So the percentage of learners that got lower than 30 would be 75% of grade 11A's learners. Okay, so that would be the answer. The percentage of learners there is 75% because they are Q3, and Q3 marks the 75% of the entire data set or the learners. Okay, so that is it for question 1. And then we move on to question 2. Okay, so we are now on question 2. And question 2 says, in the following diagram, D, okay, E, F, and G are vertices of a quadrilateral. So they don't call it any type of shape, just the quad. And then they tell us that the equation of EG, so this one, right, is this 3x minus y plus 6 is equal to 0. As you can see, it's not put in standard form yet. Then they tell us that the diagonals of the quadrilateral bisect each other at point K. So they bisect each other at point K. That's a very important thing, and we'll speak about that. And then point F is on the x-axis, and beta is the angle of inclination of EG. Okay, so the first question is, determine the size of beta. Okay, for you to determine the angle of inclination of a line, you need the gradient of that line. So the gradient of EG, as you can see, you don't have E, and that is because they told us the equation of EG. Okay, they just didn't put it in standard form. So for you to get the gradient of a line, remember that the standard equation of a line is y is equal to mx plus c. You need to get this equation to look like that. Okay, so we have 3x minus y plus 6 is equal to 0. And you can see what we had here is that the y needs to be alone. Okay, our y is kind of already alone. It's just negative right now. So you could take it over to make it positive. And then what do you have left? You just have 3x and plus 6. So your equation is just y equals 3x plus 6. And from that, you can see that your gradient is the 3, okay? Y equals mx plus c. So since it is 3, we can find the angle of inclination of that. The angle of inclination of a line, we find that by saying tan theta is equal to the gradient of that line, which is 3. Then you can find theta by saying take tan over and becomes the inverse of tan, or in other words, you're really just saying the inverse of tan on both sides of your equation, inverse of tan, right? So take tan over and becomes shift tan of 3, and then we can find that on our calculator. So what does that give us? If you say shift tan 3, you get 71 point, rounded off to 2 decimals, 57 degrees. And that is our answer over there. Okay, moving on to the next question. Okay, the next question 2.2 says, calculate the coordinates of f, given that the equation of df is x plus 3y equals 8. Let's look at f. F is here, and f is on what? It's on the x-axis, so it is an x-intercept. In order to find an x-intercept, you just have to make y equal to 0. So that's what we're going to do there. They already gave us the equation of df, right? They said this is the equation of df, and we know to find f, you just have to make y equal to 0. Okay, so that means you don't have to go stress and put this in standard form. Just make y equal to 0. So we'll have x plus 3, and then in place of y, you put 0 is equal to 8. Then just solve for x. 3 plus 0 is 0. So x plus 0 is just x, and x is equal to 8. So it means that the point f it's an x-intercept. So we have 8 and the y value is 0. And there we go. Moving on to the next question. Then 2.3 says, calculate the coordinates of E. Okay, let's look at E. E is over, we found this one. It's always good to put things down when you find them. Okay, so we found this angle, which was that 71.57 degrees, right? Just in case it's helpful. And we found this to be 8 and 0. Okay, you can just say 8 if you want. But we have those now, and they want us to find the coordinates of E. How do we find E? Well, this is where that thing they told us about your diagonals comes into play. So they said the diagonals of the quadrilateral bisect each other at the point K. The word bisect, okay? To intersect just means to cut through something. But when you bisect something, you cut that thing into two perfect halves. So when the diagonals are bisecting each other, what's actually going on is you have this line cutting this line into two perfect parts. So this part would be equal to this part. And then if this line is bisecting this other line, it means it's cutting it into two perfect halves. So that side would be equal to this side. And so from that, do you see what this means about K? If this part, if GK is equal to KE, then it means K is the midpoint of GE. And if DK is equal to KF, K is also the midpoint of DF, and this will help us to find E. So how we can find E, since K is the midpoint of both lines, do you see that DF? You have the endpoints, you have D and you have F. Why don't we find K first of all using the midpoint formula, right? Then after finding K and we have that, we will use again the midpoint formula but in the correct way and use that to find E. Okay, so let's go ahead and find K. So we're going to find K by saying, let me just put down the coordinates of D and F. So we're going to use the midpoint formula, which is, we're saying that the midpoint of DF, right, is x1 plus x2 over 2 and y1 plus y2 over 2. Now we know the midpoint of DF is that point K, so I'll just replace that and say K, right? And so x1, you can take that as your x1 and that's your x2. And of course, y1 and y2. So x1, x2, y1 and y2. So that is negative 10 plus 8 over 2 and 6 plus 0 over 2. Okay, so negative 10 plus 8, that's like saying 8 minus 10, which gives you a negative 2. So that's negative 2 over 2, which gives you negative 1. Okay, and then we have 6 plus 0, which is 6 over 2, which is 3. So our coordinates for K is negative 1 and 3. So we can fill that in. K is now negative 1 and 3. Negative 1 and 3. Now, how can we use K to find E? Well, you can also use the fact that GE, right, has a midpoint of K. So we're going to use that to find E. Since we don't know what E is, we're going to call it X and Y. And we're using the midpoint formula since we know the midpoint of this line, GE. So when using the midpoint formula, be careful not to go label this x1 and then this one x2. If you do that, you're going to find the midpoint of this little line called KG. You're going to find that. Okay, what we're going to do is label this one x1 because that's the endpoint and that x2. And this y1 and this one y2. But knowing that K is the midpoint of this. Okay, so we're using GE. So again, we're going to use the midpoint formula. But remember, this is the midpoint of GE, which is of course the same thing as the midpoint of DF. And when you're going to substitute, you see the midpoint of GE, we already know this. That is K. We saw that already. Since it is K, in place of the midpoint of GE, we're going to say that's K, which is -1 and 3. And we'll just say it's equal to, for the sake of an equation, right? It's equal to, and now we're substituting our x1 and now x2. So that is 1 plus x. Okay, so that's 1 plus x over 2. And here, that is 9 plus y over 2. So 9 plus y over 2. So here's the thing about this. You see, this is the midpoint of GE, which is of course K. This is the calculation for the midpoint of GE. So they're really the same thing, because 1 is already the midpoint. 1 is how you get to the midpoint, okay? The calculation for it. So it would mean that the x value should be exactly the same and the y value should be exactly the same. And so we're just going to equate it like that. We'll equate the x value, meaning -1, is equal to -1 equals the 1 plus x over 2. And that means that the y values are the same. So 3 is equal to 9 plus y over 2. Okay, and now we're just going to solve for x. So you can decide, because I usually say, okay, what should we get rid of to get to the x? But you can actually also do this. You can just put the -1 over 1 and then cross multiply. It would work out. Okay, so -1 times 2 gives you -2. I'll leave it there. And then saying +1 times x plus 1 stays the same, 1 plus x. Okay, and then you see, to get the x alone, you can take the 1 over. So it means that x is equal to -2 minus 1, which is -3. Okay, and then here, same thing. Okay, you can cross multiply. So you can put that over 1 and cross multiply. 1 times 9 plus y is just 9 plus y, which is equal to 3 times 2, which is 6. And so y is equal to 6, and take your 9 over, which becomes a -9. 6 minus 9 is -3. So as you can see, our x and y value are -3. So the points that we were looking for, which is E, is actually, E is -3 and -3. And that's how we find that. Okay, so that's what they mean when they say the diagonals bisect each other. Okay, it just means they cut each other. And so because they cut each other equally, they share the same midpoint. Okay, and then we move on to the last question in question 2, which is 2.4. So the last question, 2.4, says, prove that DGFE is a rhombus. So DGFE is this shape, DGFE. Okay, so they want you to prove that this is a rhombus. So this is how to prove something is a rhombus. If you need to prove that something is a rhombus, you first have to prove that it is a parallelogram. Okay, so if you want to actually prove something is a rhombus, you first have to prove that that shape is a parallelogram, okay? And there are various ways to prove that a shape is a parallelogram, okay? I don't want to really go too deep into it, but I'll show you one of the most basic way to prove that a shape is a parallelogram is if you can prove that two pairs of opposite sides are parallel. So that's parallel to that and that's parallel to that. That's one basic way. But we have to use the way that best suits what we're working with right now. And that way, I would say that the way we should use is what we showed them here. They said that the diagonals of this shape bisect each other. If the diagonals bisect each other, that is one of the ways to prove that something is a parallelogram, okay? If diagonals bisect each other, and they already told us that. So the fact that the diagonals bisect each other, it is a parallelogram. So I'm going to mention that first of all. I'm going to tell them first. It's not like it's really that necessary. I don't think it's that necessary, but I just want to still mention it first. I'll tell them first of all, DGFE is a parallelogram. And the reason it is a parallelogram is because the diagonals bisect each other. Then after showing them that, the way to prove that it is a rhombus, because remember, for it to be a rhombus, it must first be a parallelogram. Then now to prove it's a rhombus, there's actually two things that you can do. You can either prove to them that this is a parallelogram and two adjacent sides are equal, right? But if you have to show them the two adjacent sides are equal, that sounds like a lot of work because it's only for 3 marks. Now you have to find the distance of that line and that line. The second way to prove that it's a rhombus is to show them that the diagonals will bisect at 90 degrees. That will show them that it's a rhombus. Okay, so that's one way, that's the second way. But you first have to show them that the shape is a parallelogram using one of the ways to prove a shape is a parallelogram. So we're going to go with that because it seems much easier to use. Okay, so how do we show them that these diagonals bisect at 90 degrees? And there's a reason I chose the diagonals, because do you notice that throughout the questions, they already gave us the equations of the lines of these diagonals, right? So EG, which is this one, that line, its equation was 3x minus y plus 6 equals 0. So we have the equation. Okay, it's good that we have the equation because for us to show them that they bisect at 90 degrees, you just have to show them that this line is perpendicular to that line. And how you show them the lines are perpendicular is if you show them that the gradient of the first line multiplied by the gradient of the second line gives you -1. Then you know it's perpendicular. Okay, so the fact that we have the equation of this line is very helpful. Then we would need the equation of the second line because we just need to show them that the diagonals actually bisect each other. So let's go ahead and get the equation of the second line, df. They told us that already. They told us that df is this. And we know the gradient of df because we did use the gradient. Okay, we used the gradient of the first one. Okay, so we just need the gradient of df. We used the gradient of the first one and we found that its gradient was 3. Okay, so that is the gradient of line EG. So this is what I'm going to tell them. Tell them that the gradient of line EG is 3. And I need the gradient of line DF, which they gave us the equation here. So x plus 3y equals 8, right? And let's just do that. So x plus 3y equals 8. That is the equation of DF. Put it in standard form so that you can find the gradient of it, okay? Because we need the gradients of the lines. So I can say 3y is equal to, and I'll leave 8 here and take the x over, becomes a minus x. Let me rather leave it as minus x and then leave the 8 as positive 8. There we go. Then divide both sides by 3 to get y on its own. So y is equal to, you see there's actually an invisible 1 in front of this x. So we have -1 over 3x and then 8 over 3 plus 8 over 3. So you can see now that the gradient of df is -1 over 3. And so this is how I'll show them that those diagonals actually bisect each other. When you take the gradient of EG and you multiply it to the gradient of df, look at what they'll give you. That is 3 multiplied by -1 over 3. If you use your calculator or manually calculated it, you'll see that this gives you -1. And so therefore, it means that EG is perpendicular to DF. And if they are perpendicular, it means that the diagonals bisect at 90 degrees. We already knew they bisect. And now I can actually tell them that DGFE is a rhombus because the diagonals bisect at 90 degrees. Okay, and that is it for question 2. And then we move on to question 3. Okay, so we're on question 3, and question 3 says, in the diagram, A is the point -2 and -1, B, which is -3 and 4, C, 1 and 5, and D, 5 and Y. So the first question is to find the length of AC in simplified third form. So not decimal, but third form. So finding AC, as you can see, you have the coordinates of A and the coordinates of C. You just have to use the distance formula. Okay, so the distance formula is this. Okay, so remember A is -2 and -1, and C is 1 and 5. So you can just use this as your x2 and that's your x1, and then that's your y2 and your y1. So this means that we have AC is equal to the square root of x2 is 1, so that's 1 minus -2, right? Which if you multiply would become a +2, all squared plus then y2, which is 5, minus negative 1, which is 5, plus 1 all squared. Okay, so then you just have to substitute this into your calculator and calculate the value of that. And our answer for AC is 3 square root 5. Okay, in simplified third form and not decimal form. Moving on to the next question. The next question is to determine the gradient of BC. So BC is just B and C. We have the coordinates, so we can just put that down and then use the gradient formula on it. So we'll find the gradient of BC by saying y2 minus y1 over x2 minus x1. Okay, then we're just going to take y2. I'm going to start with the 5s rather. So 5 minus the 4 over 1 minus negative 3, which becomes a positive 3. Okay, 5 minus 4 is just 1. 1 plus 3 is 4. So our gradient of BC is equal to 4. Okay, grade 11s, they're making these questions really simple for you guys. So that is it. Moving on to the next question. Then 3.3 says, determine the value of y if B, C, and D are collinear. Okay, what you to know about collinear points. If points are collinear, it just means they lie on the same line. And if they lie on the same line, their gradients would be exactly the same because the gradient of a straight line is constant. It's not going to change. Okay, so we already found the gradient of BC. Why don't we make the gradient of BC equal to the gradient of CD? That's really the trick with it. You just need to take one complete point and another point. Okay, so I'm going to keep this, get this like this. Okay, so we already know that the gradient of BC is 1 over 4, which we found. So let's find the gradient of CD, but make that equal to the gradient of BC because we know they're collinear, they lie on the same line. So finding the gradient of CD, you can say y2 minus y1, and that would be, so this would be your y2 and that's your y1. That's y minus 5. Okay, so that's y minus 5 over, and then x2 minus x1, which is going to be in the CD, that is 5 minus 1. Okay, so 5 minus 1 is equal to the gradient of BC is already 1 over 4. So let's simplify. If you say y minus 5, it stays the same. Over 5 minus 1, that gives you 4. And you see that here, your denominator is also 4. In an equation with fractions, when your denominators are the same, you can drop the denominators and work with the numerators. So it means that y minus 5 equals 1. You can take the negative 5 over, and so y is going to be 1 plus 5, which gives you 6. And there we go. So y is equal to 6. That is 3.3. Moving on to the next question. Then the last question in question 3 says, if H is a new point such that AH is perpendicular to BC, determine the equation of AH. So AH is perpendicular to BC. H is a new point. Let's look at this diagram. So we have this. They said H is a new point and AH must be perpendicular to BC. So H could be somewhere here. Let's just say it was here, right? That's H. So AH, which of course would not extend naturally, it should be perpendicular to BC. So we'll just put it like that and say that it is perpendicular. So they didn't give us H, but they want us to find the equation of AH if we know that it is perpendicular to BC. What do you know about perpendicular lines? That if you take their gradients and you multiply them, they will give you -1, like we did in the previous question. So all we need to find the equation of AH, it's a straight line. You just need the gradient and at least 1 point so that you can find the y-intercept. Okay, C, because of y equals mx plus c. Okay, so we need m and c. So to find the gradient of this line, remember that we already know the gradient of BC. The gradient of BC is 1 over 4. So if the gradient of BC, since these are perpendicular, right? These two lines. And I'm starting to realize that this does not make sense with the question that they put. They said if AH, right? If H is a new point such that AH is perpendicular to BC, you need to determine the equation of AH. So what they really just mean by that is it's really just the construction. I guess AH could be this, AH, or it could be extended here as AH, and then it is perpendicular to BC. Okay, that actually seems like what they meant. I feel like they should have just said just said that find the equation of this, because making it AH doesn't really make sense. Because in the previous scenario that I drew, when I put H here, then it would not mean AH is perpendicular to BC, okay? It would mean that AH is perpendicular to CH, or AH is perpendicular to AB, not BC. So that might have been a typing error or something, because they could have, or they just decided to say that to confuse you, because they could have just said BA is perpendicular to, BC. But I see why they didn't do that, because you already have the coordinates of B, and so you would have just used the equation of a straight line to find it. So we'll just go with what they're trying to work on here and say here. So we're going to find the gradient of AH, right? The gradient of AH we'll find like that as well. We know the gradient of BC, which is perpendicular to AH. So we're just going to go ahead and tell them that it means that the gradient of BC multiplied by the gradient of AH should give you -1. And there's really a formula for this. You see, to find the gradient of AH, do you see that all you have to do is divide both sides, because you're multiplying by AH, right? To get rid of this BC, you need to divide both sides by BC. So you can actually just use that instead of using that, okay? So I'm really just going to tell them that in order for me to find the gradient of AH, I'm just going to say -1 divided by the gradient of BC, and that's all. Now, we already know the gradient of BC. The gradient of BC is 1/4. We already know that. So to find the gradient of AH, it is -1 divided by 1/4. And you can check on your calculator. That would give you -4. Okay, so we have the gradient of AH, right? What other points do we have now on AH to help us find the equation? Well, we're going to have to use A, because that's probably what they want you to use, okay? So they probably want you to use A, not B. It was just the construction that was a little weird. So we just use this -1 and -2 and -1. Okay, so our equation of our straight line is y is equal to mx plus c. You can use this, but I like to use this formula rather. Y minus y1 is equal to m times x minus x1. We know that the coordinates for A is -2 and -1. So this will serve as our x1 and our y1. So we'll say in y minus, and our y1 is -1, which if you say minus -1, it will become a +1. So you might as well just say +1 is equal to, and then substitute your gradient, which is -4. And then we're saying x minus the -2, which of course multiplies and becomes a +2. And so this is just going to be, distribute here first and then take your 1 over. So if you distribute, -4 times x is -4x, -4 times 2 is -8. Then you can take your +1 over and it becomes a -1, and you still have your y here. And so it means that y is just equal to -4x minus 9, and that is the equation of that. Okay, so that is the last question in question 3. And then we move on to question 4. Okay, so question 4 says, 4.1, in the diagram below, we have P, which is x and -24, is a point such that OP is 25 units and R is 12 and 0, with ROP, so ROP being equal to beta. Okay, so that is that reflex angle that we have there. And then they tell us that beta is greater than 180 degrees but less than 270 degrees. So the first question is to calculate the value of x. Okay, so we can go ahead and take that point and line it to the x-axis. And remember, this line is a vertical line, so it's perpendicular to the x-axis. So we have a right angle triangle and we can use Pythagoras. So this is how we have x. Okay, whatever this is, to get this point, you went that amount of units to the left and then you went down. So that is your x value and this is your y value. That's why it's negative, okay? Because negative 24 on the y-axis would be there. So that's the negative 24. So you see now we can use Pythagoras to find this by saying x squared is equal to, and since we're trying to find a shorter side, we'll say 25 squared minus the negative 24 all squared. Okay, I'm not going to calculate that yet. Now we can just go ahead and square root both sides. So with square rooting both sides, because this is an equation, you have to include the plus or minus here. Okay, so it's either that x is equal to, and I'm going to put this on the calculator and consider the plus or minus, but then choose which one will go. And we get 7. So that's plus or minus 7 that we have there. Okay, so which one is it going to be? Do you see where x is? X is on the negative part of the x-axis. So it's going to be negative 7. So that is our answer. X is equal to negative 7. Moving on to the next question. So question 4.1.2 says, determine the value of each of the following without the use of a calculator. And A, we have to find sine of beta. So now that our diagram is complete, we can actually do that. Remember that sine is the opposite over the hypotenuse. So that's what we're going to look for here. So the opposite side in reference to beta, opposite is negative 24 over the hypotenuse of 25. So sine of beta is negative 24 over 25. Moving on to the next question. The next question is cos 180 degrees minus beta. So what do you notice is being used here? You have reductions being used here. And so you have to use your reduction diagram. Where does 180 minus beta fall under? Well, it'll fall here. Remember, it's usually 180 degrees minus theta, but it's in sine's quadrant. So because we have cos, a cos function in sine's quadrant, cos is negative here. So this will get simplified to negative cos beta. And now we just have to find out what exactly negative cos beta is. So remember that cos is the adjacent over the hypotenuse. So we're going to take the side adjacent to this angle would be negative 7 over the hypotenuse of 25. So this is going to give us, remember we still have the negative here, then we have negative 7 over 25. When you distribute that, that's just going to give you 7 over 25, and that's our answer. Okay, next question. So C is tan squared of negative beta. Okay, so first of all, I noticed that the angle is negative. When your angle is negative, what should you do? You need to add 360 degrees to make the angle positive. So that's what we're going to do here. And so that will give us tan squared of 360 degrees minus beta. And you see a reduction here. So for the sake of understanding, I'm going to put that squared outside just to show you what it does to this function that we have here. So tan, and we have 360 minus beta. 360 minus theta, or beta, appears in the fourth quadrant, which is cos's quadrant. So you know that tan is negative here. So what happens is this gets reduced to negative tan of beta, but then it's still being squared. And if you square any number, okay, and it is negative, it's going to become positive because a negative times a negative is a positive, okay? So we're timesing the same thing. So this will become positive tan squared beta, and that's our answer. And then I see that I actually forgot to put the answer here. So we still have to find out what exactly tan squared of beta is. So that's like the tan of beta all squared. So let's find out what tan beta is going to be in our diagram. So tan, remember, is TOA, soccer TOA. So that is opposite over the adjacent. So it's the opposite negative 24 over the adjacent negative 7. So we're just going to have negative 24 over negative 7, which of course becomes positive. But then again, we're squaring it. So we can actually just put that onto our calculator. So that is going to be our negative 24 over our negative 7. And that gets all squared. And you see that the answer that we get, I think it can be a fraction. Yeah. So the fraction is 576 over 49. Okay. So that's what we get there. And then moving on to the next question. Okay. 4.1.3 says T is a point on OP. Okay. On OP such that OT is 15. So T is a point. Okay. So we need to show that T is this, okay, it made up these coordinates. So the x value is that and the y value is that without the use of a calculator. Okay, let's go ahead and plot down what they told us to put. I will just bring the diagram here. Okay, so here is our diagram. They told us that T is a point and it lies on OP. Because it lies on OP, it's obviously not further. So it's on OP, let's just put it there, such that OT is equal to 15 units. So we know the length of OT. And we need to now show them that the x value is that and the y value is that. Okay, so in order to find this x and y value, okay, let me just put this in red. You're going to have to think about it like this. It is still on this same line, right? So if you construct a triangle as well, guess what? The reference angle is still going to be beta. So we can actually use what we found out about this bigger triangle, okay, in reference to beta, like its sine of beta, its cos of beta, its tan of beta, and we can actually use that to find this. So remember, they want you to find the x value and the y value. And how we can think about that is, in order to find the x value of this triangle OT and then whatever that is, right? To find that x value, what you're going to have to think of is the x value in reference to your beta, because that's beta again, right? The x is your what side? That is your adjacent side. So that's adjacent. And the only other side that you actually have is this 15 units, which is your hypotenuse. So we're going to have to use cos. But cos of what? Well, our reference angle is beta. There's nothing else we can use. Our reference angle is that beta, right? So we have to use cos of beta to find it. So this is really what we're saying. We're saying cos of beta is equal to, and we're using this little red triangle, and we're saying it's equal to the adjacent over the hypotenuse. So that is x over 15. But the thing is that cos of beta also has another value if you're using the bigger triangle. Well, it's the same value really. So cos of beta in the bigger triangle, we already found that here. So remember, we had negative cos beta. So you know that cos beta is negative 7 over 25. You can also look at it from here, adjacent over hypotenuse. So cos beta is also equal to negative 7 over 25. They're both in relation to beta, and that's what's tying them together, because they lie on the same line. So their reference angle is the same size. All these is really just ratios. So cos of beta is that negative 7 over 25. And we know that is equal to x over 15. And now you see that you have an equation. And we can solve for x now. So to get x on its own, you just have to get rid of the 15. So we could just multiply both sides by 15. So x would be equal to whatever 15 times negative 7 over 25 is. And let's go ahead and find that. And you see that that is negative 21 over 5. Just like they have, that's their x value as well. Okay, negative 21 over 5. Now to find the y value, you also have to think in the same direction. I'll just keep using that 15 then. To find the y value of this point, right, the y value, you have to think about it like this. In reference to your angle beta, y is opposite. And we also have this. So you could use x this time because you already have x. But I'll just stick with using the hypotenuse. It's 15. So this time I'm going to use the y and the 15. So that's the opposite and the hypotenuse. Opposite over hypotenuse is the function for sine. So this time we're going to use sine. Sine of beta is equal to, and we're saying the opposite is the y over, let me just put it like this, over the hypotenuse, which is 15. But we also know sine of beta, right, in the bigger triangle, because they are using the same reference angle. Sine of beta there was negative 24 over 25, opposite over hypotenuse. So negative 24 over 25 is therefore equal to the y over 15. Okay, again, to get y alone, get rid of the denominator of 15. It's dividing by 15. So you multiply by 15 to get rid of it on both sides because it is an equation. So just go ahead and say y is equal to, and say 15 times negative 24 over 25. And you see that y is equal to negative 72 over 5. And that's our answer there. Okay, negative 72 over 5. And that's what we have there as well for y. So that therefore tells us that t, the points, okay, I'll just put it here. So that point t is really negative 21 over 5. And the y value is negative 72 over 5. And that is there. That's how we prove that. Okay, moving on to the next question, and that is B of this question. Okay, so in B, they want us to determine the area of ROT, triangle ROT. That is an interesting question. So look at that. ROT is ROT, right? So just connect R and T, and this is the triangle they want us to find the area of. Okay, so remember this is 15. This was our X, which we found already, and the Y, of course. So finding the area of this, as you can see, it's not a right angle triangle. However, it does have a perpendicular height. You see, this triangle is an obtuse triangle. You just have to tilt your head this way, and then you can kind of see it's an obtuse triangle that is just sitting like that. It does have a perpendicular height. Okay, technically it does have that. So that height is this over here, because from the highest point of the triangle to the base of the triangle, you can see that the perpendicular height is whatever this is. Okay, so that is the height of it. If it was grade 12, we could just use another rule called the area rule to find the area of this triangle. But this is grade 11. I just remembered it. I was about to use the other rule now. So what we're going to do is we have the height of it. This is the height of the triangle. Okay, if you tilt your head, you see the way this is an obtuse triangle. So highest to the base of the triangle. So what exactly is the height? What is the distance? What is this? Remember that t is here, right? You found this when we found this part. That was our y value. This one was our x value. So that is going to be the distance. That's exactly what your height is. So the y value of t, which is this number, negative 72 over 5. Okay, that's our height. And then you need the base as well. Remember, the base works like this. It's the base, not from the height. You can't take that whole thing as the base. No, it's just this part over here that is your base. So you see, from O to R, how far is that? That is just going to be 12 units. So see, because you go 0 to 12, that's only 12 units. So you have your base and you have your height. You can use the area of a triangle, which is a half, times the base times the height. And that's what we're going to do there. So tell them half base times height, area of our triangle ROT is equal to a half times our base, and our base is 12 multiplied by our height, so 12 multiplied by our height, which is that negative 72. But we can't take it as negative because it's a height. You see, if you're speaking about the area, sure, it is negative, but as a distance, it is positive. So the distance there is positive 72 over 5. That's what we're going to take there. Okay, so you just multiply that and we're going to get our area. So you see that as a fraction, what we get is 432 over 5. As a decimal, it's fine because it just has one decimal anyway. So 76.4 units squared, because this is area or squared units. So units squared, still fine. So there we go. That is that question. And then we move on to the last question in question 4. The last question says simplify to a single trigonometric ratio. So this is 4.2. And we have tan of 225. Okay. So we just have to simplify this. Okay. So what I like to do is I like to look at the numerator and denominator separately just to see how many terms we have. On the numerator, you see that we have a plus sign here. So it means that this is one term on its own and that is one single term on its own. So we have two terms there. Just remember that. On the denominator, we just have one single term. So how can we simplify tan 225? Well, you have to think about it using your reduction diagram. So which looks like that. You have to make sure you study your reduction diagram. And so when you look at this, the angle that you're going to have here when we're measuring, we start from 0 degrees. Then this is 90 degrees. And then this is angles on a straight line, 180 degrees. This is 270 degrees because you see you're just adding 90 every time. and then back at 360 degrees. So where would 225 degrees fall under? That is greater than 180, but less than 270. So it will have that reduction. So what we're going to do here is say tan of 180 degrees plus what is going to give us 225. And that would be 45. Okay. Then we have here, that's just, you see that we just have to reduce that. What is sine of 180 minus theta? Sine of 180 minus theta, it's in sine's quadrant. So it's going to simplify to just positive sine theta. And then we have cos 90 degrees plus theta. And remember your cofunctions. Here's a diagram for you to remember your cofunctions. Okay, so it means that cos 90 degrees plus theta, that's the only one that becomes negative, remember? So that one becomes negative sine theta. Okay, so I put it in brackets because you see those two, they're still multiplying. Then we can say over, and here, again, remember your cofunctions. Cos 90 minus theta would give you positive sine theta, and then this. So you see what's going on here. You have negative theta minus 540 degrees. Your angle is negative. What should you do when the angle is negative? Well, you have to add 360 degrees to it until it becomes positive. So if you take negative 540, right? Negative 540, and you add 360, you see you still have a negative angle. Add 360 again to make it positive. So again, plus 360, and now it's positive. It's 180 degrees. So what you actually have there, so we have that part, then we have this. So it's sine, and it became 180 degrees. So we still have the negative theta, right? But it's best to put your angle first. So put the 180 degrees that you got from adding the 360s, and then you still have a negative theta, which is minus theta. So you see, it just creates a reduction again for sine. Okay, let's reduce. So here, tan 180 plus 45, it is in tan's quadrant, okay, 180 plus theta. So it becomes positive tan of your reference angle, 45. And then here we have plus, you just have positive, okay, well, I can't say plus yet. This is positive sine theta times negative sine theta, which would give you negative sine squared theta. Okay, it's like 1 times negative 1. Gives you negative 1, okay? Or really just like a times negative a. It's negative a squared, okay? So that is over, and we just have sine theta multiplied by sine 180 minus theta. According to your reduction, it's in the correct quadrant, so it reduces to sine theta. Okay, so that is just equal to, well, tan 45 using the calculator, if you want to use a rule called the OHA rule, but the calculator will be fine here. Tan 45 gives you 1, and you have minus sine squared theta. And this is over sine theta times sine theta gives you sine squared theta. Okay, so we're not done yet. You have 1 minus sine squared theta. Where do you remember that? If you take sine squared theta plus cos squared theta, it gives you 1. If you leave cos squared theta here, cos squared theta will be equal to, you see you still have 1, and you have to take sine squared theta over. So that's what's equal to 1 minus sine squared theta. It's cos squared theta. So I'm going to change that to cos squared theta, and you have that being over sine squared theta. So here's a thing here that you need to remember. Please remember that tan theta is equal to sine theta over cos theta, not cos theta over sine theta, right? So it means that this one is not really going to change unless you want to change it to the reciprocals. Okay, the reciprocals are so of sine, cos, and tan. The reciprocal of tan, right, meaning 1 over tan theta, that is the one that's equal to cos theta over sine theta. This is probably something you learned early in grade 10. Okay, so this, the only thing it can actually change to is 1 over tan theta, which tan squared theta really, okay, because they're both squared as well, which really just becomes, so 1 over tan theta is actually equal to cot or cotan theta. So the only thing that this can actually become is cotan squared theta. Okay, not tan squared, because it's cos over sine, not sine over cos. Sine over cos is tan. So that is the answer simplified. Well, you guys don't really deal with these but they are there. Okay, it's still in maths. So that is the last question in question 4. And then we finally move on to question 5. Okay, so now we're on question 5, and question 5 says, in the diagram below, f of x is equal to a cos of a half x minus a half. Okay, so that graph, it's a cos graph, but we have a, meaning there's some sort of amplitude being put there. It could be positive, it could be negative, but we'll see what exactly it is based on the way the graph looks. And we also have minus a half. Okay, so when you have a graph, even in functions, right? Let's say you have a graph as y is equal to x, right? That would just be a straight line like that, diagonal line. But then if you have y is equal to x minus 2, okay, you're subtracting 2 from the function that you had, then it would mean that this line is moving down. Okay, so we know that that graph has been shifted down as well. And then they tell us that we have, and g of x is equal to negative 2 sine of x plus p. So in this one, you see, they both translations going on. Here in this graph, the graph is shifting down. We also see something happening here with the x. So the period of the graph has changed. And then here in this graph, there's also a shift going on. But you see, this shift is by the x, right? It's x plus something or minus something. So it means that this is either moving to the left or the right. But as for this one, we can see that this is moving a half units down, you see, because you're taking the function and you're subtracting by that. You're not doing that to the x. So this one is moving down. Okay, so it's a good thing to just analyze it. And they tell us that these graphs are drawn for where x is an element of negative 240 degrees all the way to 240 degrees. So the first question is, write down the amplitude of G. Okay, so let's look at G. G is our sine graph, right? This is this graph over here, the sine graph. And they want us to tell them the amplitude. Well, do you see that in front of sine, you have negative 2? The amplitude is really just the height of the graph from the midline. So from the middle of the graph, the height of the graph. Another easy way to find the amplitude is take the maximum, right? The absolute value, meaning if it's negative, just take it as a positive. Take the maximum plus the minimum of the graph and divide it by 2. So the highest that this graph has gone to is 2. The lowest it goes to is negative 2. So that's 2 plus 2 and then divided by 2, which will give you 2. Okay, so we know the amplitude is 2 because you can see from the middle of the graph, the highest it reaches, the height of this graph is 2. Okay, so that is our amplitude. We can just tell them that the amplitude of G is 2. Okay, so that is 5.1. And then we move on to the next question. The next question, 5.2, says determine the period of F. So let's look at the graph F. The graph F is this one, which is our cos graph. Okay, so the period of F. So here's the thing. Do you see that next to your x, we have a coefficient? So it means that the period has been altered. The period has now been changed. And this is how we can find it. So to find the new period of a graph, okay, period, what you're going to do is take the original period of that graph, meaning is it a sine graph or is it a cos graph or tan graph, right? You take the original period of that graph and then you're going to divide by the coefficient of x, meaning whatever number was in front of x. Okay, we're going to divide by that. And let's go ahead and call that number k, right? So the new period is going to be equal to the original period of that graph. Do you see that the graph of f is a cos graph? Because it's a cos graph, the original period of a cos graph is 360 degrees. It takes a cos graph 360 degrees to complete one cycle. Okay, so it means that we're just going to say this original period of 360 degrees divided by k, and we know that k, the number in front of x, is a half, so divided by a half. And that gives us, if you divide that, that will give you 720 degrees. So what this actually means for your graph is, you see your original cos graph. It used to take, and let me actually just put it like, your original cos graph, right? Within 360 degrees, it used to complete one cycle, like that. But now what's going to happen is, this cos graph's period has been altered, and now it's going to complete a cycle, not in 360 degrees anymore, but now in 720 degrees. So what happens is this graph really just gets stretched. And now it's taking longer for it to complete a cycle. I'll keep this here for reference just in case we maybe need it. Okay, so that is the period of this graph. Okay, moving on to the next question. Okay, so 5.3 says, determine the values of A and P. Okay, so let's look at A and P. So with A, that is referring to the coefficient of cos. Okay, let's actually just find P first, because I feel like the sine graph is just so much more simple to look at. So for the cos graph, we'll look at what the original graph looks like and look at those key points to find out what exactly it's going to be. So let's try to find P. So you see that you have x plus P, right? So P could either be a positive or a negative number. And what's going on is that this graph is shifting either to the left or to the right. So let's look at our sine graph. First of all, you have -2 sine. Okay, so that is already a big thing. So let's look at what the original function of sine would look like. The original function of sine would look like this. Starting at 0, remember the key points. That's one thing you need to really take note of, the key points. At 0 degrees, your y value is 0, right? At 90 degrees, which is somewhere here, our y value is supposed to be 1. But of course, because we have negative sine, right, -2 sine, let's just think about it as our original function. Let's make our original function be y is equal to 2 sine of x, right? I'm looking at this graph just because I know that it's supposed to go till 2 and not 1 instead. So at 90 degrees, that's where we would get a y value of 2, right? This is if I didn't make that negative, of course. And then at 180 degrees, you have 0. Then at 270 degrees, you'd have -1. And then 360, you'd have 0. Okay, so your sine graph, again, it's just a curve that kind of looks like that, right? Curves like that. And so now we can compare this, because this is the one where this is positive, right? We can compare this to this one. First of all, we know that they made the coefficient of sine to be negative. So it's not +2, it's -2. So what's actually going on there, it's kind of like taking this sine graph and reflecting it across the x-axis. So all your y values get multiplied by -1, right? So the y value here would have been 0. If you multiply that by the -1, it will still be 0. Here the y value is 2, but the y value, if you change that to a -2, instead of it being 2, it will be -2. Okay, then the 0 y value will still be 0, because if you times that by -1, it's still 0. Then the one that is supposed to be -2, right? That y value is going to now become a +2 because we multiply by -1. I'm just changing that so I can see what it looks like now. So it means that if you change that to a negative, your sine graph is going to look like this, something like that. Okay, so that's what it looks like. And that's what this one is doing. So now we can compare this graph to this one so that we can understand how it was shifted. Since now we have a graph of y is equal to -2 sine x. This is our graph here. Okay, so if you look at this graph, what is it actually doing? You have to focus on the key points. So things like where it's equal to 0, the peak of the graph, the highest point, the maximum, the minimum of the graph, things like that. Now, right now, the maximum and the minimum, we can't really see the numbers properly, so we're not going to assume it's anything. Let's focus on one that we can actually see clearly, which is 0 degrees. You see, at 0 degrees, this sine graph should have a y value of 0. So let's look at the 0 rather. So this sine graph, right, the -2 sine x, where our y value is 0, that happens at 0 degrees. You see that that is on the line. So that's where the y value is 0. But this one that they drew, look at where the y value is 0. It's 0 at 60 degrees. So what this means is that this graph that used to look like this, it actually moved like this. And that's why it looked like that. Okay. So this part that you're seeing is really just the repetition of the graph. Remember that the sine graph and the cos graph, they just keep going on, right? You have a sine graph and it does this at first and it ends at 360 degrees. 360 degrees later again, it will do that. Okay, and even 360 before, it will do that again. Okay, it goes up and then down and then there. So that's this part that we're seeing here. So this graph moved from here, where it was at 0, and it moved to what direction? It moved to the right by 60 degrees. So that's what's going on. So let's actually translate that into what it's going to be in the equation. Remember, if you are moving to the left, we say plus. If you're moving to the right, you say minus. That's how it works when you're affecting the x. It doesn't work for up and down movements. With up and down, if it's down, it's minus. If it's up, it's plus. So it means that we know that this graph moved 60 degrees to the right. It means that here you should have x minus 60 degrees. So do you see the value of p? P is equal to negative 60 degrees. And that's how we find that. Okay, so you have to think about what the original function looked like. P is equal to negative 60 degrees. And we found P. Now we have to find the value of A. So what is A? A is our cos graph, right? So let's look at what that is going to be. Let me just erase these. Okay, so now let's look at that cos graph and see what exactly is this value of A. Again, let's think about what the original cos graph would have looked like. Remember how I showed you what happens with the period, right? That this period, because it was a half, it actually stretched out the graph and it made the graph complete a cycle in 720 degrees. So it takes longer for it to actually complete one cycle. Remember that the cos cycle, right? It looks like that. It's really just a pattern. It's like the y value is 1, y value is 0, y value is negative 1, y value is 0, y value is 1. Okay, and all over again. 1, 0, negative 1, 0, 1. It just keeps going. So let's look at what it's going to look like here and compare it to the cos graph that we have over here. So you know that the normal cos graph, right? You can use your calculator to find out what it looks like. So that normal cos graph, the original cos graph, the mother graph, is cos of x, right? So you know that at 0 degrees, your cos graph is equal to 1. You can substitute if you want, just so that you remember what it looks like. But you should already just study the patterns of the way the graphs look. So you know that it should be at 1 and then 90 degrees later, and that's one thing. It goes in intervals of 90, right? So 90 degrees later, you're going to have your cos graph being equal to 0. 90 degrees later, it's going to be equal to negative 1. 90 degrees later, it's going to be equal to 0. And then at 360, it's 1, right? So your cos graph naturally is supposed to look something like this. Not the best drawing, but something like that, right? But now it's going to be stretched out. So as you see what happened with the period used to be 360 degrees, is now 720 degrees. That is double of that. That's exactly what's going to happen with your angles as well. So 0 degrees, if you take 0 degrees and you times it by 2, because it needs to be double of it, it's still 0. That's why at 0 degrees, you still have a y value of 1. Stay the same. But then you'll start noticing those changes at things like 90 degrees, for example. So now at 90 degrees, right, you see the y value of 0, it's not going to happen at 90 degrees anymore. It's going to happen at double of that, which is times 2, which is 180 degrees. So what was supposed to happen there will now happen here. Now you have a y value of 0. Then remember at 180 degrees, you had a y value of negative 1. That's not going to happen at 180 degrees anymore. That's going to happen at 180 degrees times 2. That is 360 degrees. So at 360 degrees, that's where you have a y value of negative 1. Okay, so you can already see how stretched out that graph is. And then it's going to do the same thing on this side as well. So here at negative 90 degrees, that you're not going to have your 0 there anymore. You're going to have that at negative 180 degrees. And then at negative 180 degrees, where you're supposed to have your y value of negative 1, you will have that at negative 360 degrees. So you see what happens. Your graph looks something like this. Okay, let me just draw that out. So something like that. So now the graph that we have is really y is equal to cos of a half x. That's what we have now, right? And now you can compare that to this one. Do you see what's going on? Look at key points. So at 0 degrees, your y value was supposed to be 1. But you can see now your y value is negative. Okay. But you also have to consider that this graph was shifted a half units down. So if this graph, right, had a y value that was negative, let's say just make it negative, right, cos of a half x, it would mean that it's just going to be reflected across the x-axis. So where you had 1, okay, your y values just get multiplied by -1. So where you had 1, you now have -1, okay? And then the zeros will stay the same because 0 times -1 is still 0, and that's still 0, okay? So that would make your graph now look something like this, okay? A lot similar to the one that you have. And so when they said -1/2, then it shifted down a half units. Okay, so that's how that graph was formed. And so that would make the value of A just be equal to -1, because that's what we did there to actually make it look like that. Then we just shifted it down by half. So that's A. So P is -60 degrees and A is equal to -1. So you see grade 11s, it's all about knowing what the original function looked like. Then you can see how they came about with those ones, even if they didn't give you all these clues and hints. Okay, so that is that question. And then we move on to the next question. Okay, 5.4 says, for which values of x is f of x multiplied by g of x less than or equal to 0? Okay, so let's speak about what would give us values less than or equal to 0 first of all. You see, we are taking f of x, meaning the y values of f, and we're multiplying it by g of x, the y values of g. And they need to give us values that are less than or equal to 0. So it means that, of course, for it to be equal to 0, either one of it must be equal to 0 or both of them can be equal to 0. And then that works out. And then for less than 0, what should happen is your f, right, the graph of f, the y values can be positive, and then the y values of g can be negative. Then you would get a value less than 0, which is a negative number. Okay. Or it could be a case where your graph of f has negative y values and your graph of g has positive y values, and then you'll get negative again. So this is what we're looking for. And of course, we're also looking for cases where they are equal to 0 as well. Okay, one of it is equal to 0 or both of them are equal to 0. So let's go ahead and look for this. Okay, so when we're looking at our graph, something that really helps is if you use a vertical line. So I use this vertical line, you can use a ruler. Okay, that's going to help a lot. So we're going to look through the graph and we're going to look for places where the graph is either one graph is positive and the other one is negative. So remember, these are their y values. Okay, let's start from -240 degrees. You see that at -240 degrees, the y value there is 0, right? And at G, the y value is some negative number. So of course, if you take 0 times the negative number, it will give you 0, which is one of the requirements we want for them to give you 0. So we'll definitely take that. So I'll put a mark there so I know I'm going to take that. Okay, let's keep moving with our vertical line. So if you keep going, you see like here, for example, the y value of the graph of f is negative. The y value of the graph of G is negative. So that's not going to work because a negative times a negative will give you a positive. We needed to give us a negative. And if we keep going, you see, still has a negative and a negative. That's not what we want. Negative and negative. Even right here at that point of intersection, they're the same values, but they're both negative. Okay, keep going. It's still negative and negative until we get here. So you see that here, right? The graph of G is on the x-axis. So its y value is 0. And if you take the 0 and you multiply by that y value, which is a negative something, right? That will be 0 times that negative, which gives you 0, which is what we're looking for as well. So let's mark that. We'll definitely take that. Okay, so you use a vertical line because you're trying to make sure it's for the same x value. That's what it needs to be, for the same x value. Okay, so that. Now if you keep moving on, look at what happens. You have a positive y value and a negative y value, which is what we want. We want it to either be positive or negative at the same time, which is what we want. We want them to be positive and negative at the same time, because if you take the positive times that negative, it gives you a negative. Okay, so it's working there. It's also working here. Keeps working and it keeps working. See, positive and negative until we get here. Okay, then here it's 0. Okay, the y value is 0, then the y value is negative. So that's also included because 0 times the negative is still 0. We want that. And then, of course, when we go after, It's negative and negative. So let's mark that one that just worked out. We see that all through here till the positive 60, sorry, right? All of this worked. So we're definitely going to include that. All of that worked. And if you keep going on, you see that here they're both negative, still both negative, still both negative, until we get to 240 degrees, okay? At 240 degrees, what's going on is they're both equal to 0, which we can take because when you multiply the y values, they must either give you 0 or be negative, so we can take that as well. So there, these are our solutions. Now we just have to actually write them down. So first of all, you see that here at negative 240 degrees it worked. So for that part, we can say that x is equal to negative 240 degrees, okay, because that works. And then for this part, you see what's going on. It works at negative 120 and 60, and then it works for values that are moving towards this direction, values that are greater than negative 120 degrees, but less than 60 degrees. It works all through for both graphs, of course. So we're going to say there, x needs to be greater than negative 120 degrees, but greater or equal to, okay? The reason why is because at negative 120, you have 0 and negative, which give you a 0. And less than or equal to 60 degrees. So I'll say or, okay? And then the last solution, it works at 240. So or x is equal to 240 degrees. And that will be all of the answers that you have there. Okay, so this is our solution for that question. Okay, and then we move on to the last question, which is 5.5. And now we are on 5.5, and it says if h of x is equal to 2 cos x plus k. So this is a new graph. It's a cos graph, and it's also shifted to the left or right. And we have a coefficient of 2 at cos. So, and they tell us an h of x is equal to g of x. So the y values must be exactly the same. You need to write down the possible value for k. Okay, so this is something that I feel like I can best explain with a drawing of the graphs, really. So let's think about what they want us to do, right? They're telling us there's a new graph, and the equation of that graph is 2 cos x plus k. And they tell us that h of x must be equal to g of x. Remember that g of x, right? If we look above, g of x was negative 2 sine x, and we know what p is now, right? We found that at p was negative 60 degrees, right? So it means that that graph, right, is y is equal to negative 2 sine x minus 60 degrees. They're telling us that if h of x is equal to g of x, meaning both of those graphs align perfectly however they may look, that they sit on each other perfectly, right? We need to write down the possible value for k for which this will happen. Okay, it's a very interesting question because it's actually going to teach you something or help you realize something about the cos and the sine graph. In a way, the cos and the sine graph, they kind of seem like the same graph. Okay, they're not really the same graph, but they can fit perfectly onto each other. So let me show you what I mean by that. So if we have, right, let's just speak about a sine graph first of all. Let me rather move this a little more to the left, and I need that to be straight. Okay, so let's say this is here, and we have a sine graph. So our sine graph looks like this, right? So that's just y equals sine of x. So if we have that graph, you can see that we can actually form a cos graph out of this. So a cos graph can be formed by actually taking this same sine graph, and what we're going to do is we're going to take that and copy it. Let's just have two sine graphs. I'll show you that we can actually form a cos graph with a sine graph by putting two sine graphs, and let's extend that. And we're just going to have to erase some parts of this graph. We're going to see that, remember that the cos graph looks like that, right? We can actually form that here. Let's just erase the part of this graph that's going to help us form this. So if I erase this part, that is gone, and I erase this part, all of that. Do you see now that we have a cos graph? Okay, so that's what I mean by a sine graph and a cos graph. They're very similar. So what could happen is there's a way you can take the cos graph and actually shift it to the point that it fits perfectly with the sine graph. That's actually what they're trying to play around with here. But let's just be careful to use the graphs that they gave us already. Remember that g of x is equal to negative 2 sine x minus 60 degrees. Okay, so let's just look at what that graph would look like. We already have it in our diagram though. So that's our original cos graph, and we're just going to form this one. Okay, so just remember, naturally the sine graph, right, at 0 degrees you have a y value of 0, then at 90 degrees that's where your y value of 1 would be, right? And then at 180 you're going to have your y value of 0, and then 270, that's where you have a y value of negative 1, and then 360 you have 0. But let's also just remember that this is negative 2 sine. Okay, so let's just change that to positive 2 and negative 2. Now I know right now the graph that we have is 2 sine of x. Of course, if you make that negative, it's going to make your graph really just do that. Okay, and I don't want to redraw this graph because I'm trying to use the same pattern so that it aligns with it perfectly. So what I'm going to do is I'm just going to copy this graph again and form another sine graph from this. So like this. So you know that if you make that negative, what it's going to do is make this be reflected across the x-axis. And so it's going to do this angle up and then go down. Okay, and I can already see that shape in the sine graph over here. So I'm just going to cut away those parts so that I can have that shape. So that, and cut away that. Okay, so that's what the sine graph would look like if you made it negative 2 sine of x. We're still going to account for the negative 60 degrees, okay, the shift. So if we take this graph as it is, and it's naturally just here, then you have to move this graph because it says minus 60 degrees. We're moving it 60 degrees to the right. Okay, so let's just put down here that this is now 60 degrees. The y value of 0 is at the x value 60 degrees. So really, this is the graph that we have now. This is our graph of g. Right, and our graph of g is that negative 2 sine of that. That is our graph of g that we have there. So the graph that they're referring to, this new graph of h, is taking a cos graph, and it is 2 cos of x plus that. So you see the only thing that changed here right now is just that 2. It's not negative, it's positive. So we can just let this graph, it's still a normal cos graph, but the highest it will go is 2 and the lowest it will go is negative 2. So the question is, how can we actually, if we know that h of x is supposed to be equal to 2 cos of x plus k, how should we actually shift this graph so that it can align perfectly with this, meaning your y values are going to be the same, exactly the same? So that's the question here. We can take this graph. So this is what you would be thinking about when you are aligning it. Not necessarily picking it up and moving it, but what you can actually do is, in your head, you're going to think about the key points. Do you see that here on the cos graph? The y value of 0, you're going to have to think about what that used to be. The y value of 0 on the cos graph would have happened at 90 degrees. Because at 0 degrees, your y value is 1. If you say cos of 90, you will get 0. Okay, and then the y value at 180 degrees would have been negative 1, and then at 270 degrees would have been 0, and then 360 would have been 1. So you're looking at key points. So we're taking this graph of cos and then seeing how we can actually move it so that it perfectly aligns with this one. Focus on a key point. A key points that we have is here, this 90 degrees, the y value is 0. So it means that your cos graph, if I put it here, it would have looked like this. So how should we move it though? Because you see that the sine graph, where it has a y value of 0, that is at 60 degrees. So if here you have a y value of 0 at 90 degrees, you should move it how many degrees to the left? You should move it by 30 degrees to the left so that you get to 60 degrees. That's actually what's going on there. So that k that we have there, that k is 30 degrees to the left. Remember, when you're moving to the left, you say plus. Okay, so it's a positive value. And we know it's positive. It's moving 30 degrees to the left. So that is positive 30 degrees. And that would be your value of k. So it means that k is really just equal to 30 degrees. It has to do with you thinking about the graphs and how it can align perfectly. I just had to draw it down just so that you'll see, but you could have used the diagram that they already gave you. So it would have been quicker. Okay, so that is it for that question. And that is it for question 5 in this paper. And then we move on to question 6, which is on 2 and 3D trigonometry. Okay, so now we're on question 6, and question 6 says, a candle holder is made in the shape of a hemisphere where a conical section is drilled out for the candle wax. So we have this, it's a candle holder, like a bowl really, and then we have this conical shape that we have. So not really a cone inside, it's drilled out of that shape. Okay, then they tell us that in the diagram below, the radius of the hemisphere is represented by big letter R. So that's the radius of that hemisphere. That, and that makes sense because it is a hemisphere. And then we have where ST is equal to VT. Okay, so that is equal to that. Those are both R. The radius of the cone is represented by R. So this is of the little cone here. That is small letter R, where TW is equal to R. The angle at the vertex of the cone is given by theta. Okay, so that angle, you're just really going from that line, okay, to that line. And so if you're looking at it as a flat shape, it is just that angle over there. Okay, so then they give us some formulas. They give us the volume of a sphere, not a hemisphere. Okay, so you have to find the hemisphere by thinking about if a sphere is this, then the hemisphere would be half of it. So you just have to multiply that by a half or divide by 2, however you want to do that. And then they also give us the volume, the formula for the volume of a cone. Okay. The first question is to express small letter r in terms of big letter R and theta. So let's look at that. They want us to actually just ultimately find the radius of the cone. Let's think about how we can find that. Okay, so if you're trying to find the radius of the cone, you see that TV, right? That R, big letter R, because it's the radius of the hemisphere, it is perpendicular to this line, okay, from WT. You can just say WT. So we can actually form a right angle triangle there. So if we draw that, you see that we have a right angle triangle like this. But the angle that we're going to have now in this right angle triangle, because from this line to this line, if you measure that angle, it was theta. But now you see that because this line is perpendicular, what it's going to do is it's a perpendicular bisector of this angle, this whole angle theta here. It's cutting it in half really. So taking half of that. And so this angle that we have here, we can just call that theta over 2. Okay, because we're dividing that angle by 2. So we have our 90 degree, we have theta over 2. We need to find R in terms of theta and big letter R. Well, TV, right? TV is the radius of your hemisphere. So that is big letter R. So do you see that we can actually use trigonometry here to do that? This is 2 and 3D trig. So what we can do is look at the fact that our reference angle is theta over 2, this angle. And they want us to find R. So we're definitely going to use that side. And we also need to find it in terms of this big letter R. So the sides you're using in reference to your reference angle is the opposite and the adjacent side. So you see we have to use the function of tan. So tan of, and our angle is theta over 2, is equal to, and we have an opposite side of R, right? So opposite over adjacent for TOA. And the adjacent side is big letter R. But here's the thing. They said express R, small letter r, in terms of this. So we need to make that the subject of the formula. Okay, so we just need to find the value of R, or really just make R the subject of this equation. So to do that, you see that you just have to get rid of the R, the big R on the denominator. So we're going to multiply both sides by the big R. And so that would mean that you just have, well, let me just say R is equal to, because that cancels out here, is equal to, and then what we're left with here is R tan of theta over 2. Let me actually put this in brackets because that's an angle. It's not like, you know, an expression like that. Okay, so that is what R is, expressing R in terms of big letter R and theta. Okay, moving on to the next question. The next question, 6.2, says, show that the remaining volume of the hemisphere can be represented by this. Okay, so we're really just trying to find the remaining volume of the hemisphere. So remaining volume of that hemisphere. So let's look at what they mean. You see, you have the entire hemisphere. They're saying when they cut that part out for the wax, they want to find the remaining volume of that hemisphere. So in order to find that, you can think about it like this. To find the remaining volume, we're just going to take the volume of the entire hemisphere, okay? I'll just call that the whole hemisphere, the volume of that, and you subtract it by the volume of the cone. Okay, so if you remove the cone part, that's all that's going to be left, minus the volume of the cone. That's all we have to do. So you see, in order to do this, you just need to find the whole hemisphere, the volume of that, and then the volume of the cone. Okay, so let's go ahead and do that. Okay, so to find the volume of the hemisphere, remember that a sphere, the volume of a sphere is 4/3 pi r cubed, right? They say in big letter R, of course, because that is the radius of the hemisphere. So to find the volume of a hemisphere, not a sphere, you would have to get half of that. So you can just multiply this by a half. And you see that the only numbers here is the 4/3 and the half. So if you take 4/3 and multiply it by a half, diagonally, you see that we have a common factor of 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. So what you'll be left with there is 2 times 1, which is 2, and 3 times 1, which is 3. So you see that all we have there is just 2/3, and then still the pi and the r cubed. That is the volume of the hemisphere. So we're going to use that. And I'm sure we're supposed to actually put that calculation here. So I'll put it down here. Okay, so that is that we have now. So that is how we're going to find the volume of the hemisphere. We haven't really been given anything else. We only found r in terms of that. And as you can see, we don't even have any small letter r here. So we can move on to finding the volume of the cone. Okay, so volume of cone, how would we find that? Well, they already gave us the equation for the volume, or the formula for the volume of a cone. It's 1/3 pi r squared times h. So if that is 1/3 pi small letter r squared times h, let's just fill in what we need to. Remember, we already found an expression for r, so we'll put that in. And let's actually just see what exactly is h, because that's the only unknown things that we have here in this formula. So the height, right, of this cone is this. But do you remember that st is equal to tv, because that is the radius of the sphere. So that, instead of calling that the height or tb, you call that r, because that's the radius of your sphere. Okay, so that's what we're doing. So we're saying 1/3 pi, and in place of r, let's just substitute what r is. R here is r tan theta over 2. So that is multiplied by, but remember it's squared. So let's just say r tan theta over 2, and then we need to square that. Squared, and then multiply by h. And of course the h is that big letter r, okay? That's the radius of the sphere. So multiply that by r. Okay, let's just simplify this now. So the volume of our cone is, we don't have any other numbers apart from 1/3. So 1/3 pi, then this whole thing is squared. So r gets squared, giving you r squared, and tan will give you tan squared theta over 2, and then multiply by r. Okay, so the r's need to still multiply, and so the volume here is going to be 1/3 pi r to the power of 3, because those r's multiply, and then tan squared theta over 2. Okay, so that is the volume of the hemisphere and the volume of the cone. So remember, to find the remaining, okay, the remaining part of that hemisphere when the cone has been cut out, you're just going to take the volume of the hemisphere and subtract it by the volume of the cone. So that is the 2/3 pi big letter r cubed minus, now it's just one term, so there's no issue with that. We're just going to have to say minus that we have there. Okay, so minus this. Now let's look at this. How can we actually simplify this? Well, first of all, they're not really like terms because of the tan squared theta over 2. That doesn't have tan squared theta over 2, but it does have everything else. So why don't we just simplify it by taking out a common factor? Okay, so between 2 over 3 and 1 over 3, what's common? You can look at it as between the numerators, what is common? You're going to have 1 common in the numerator, and on the denominator, do you see what's common? 3 is common in both. And then pi is common in both terms. R cubed is also common in both terms. And now if we open our bracket, what is left in the first term? So what do you multiply to this to get back to that? Or you could even just say this divided by that. You see that everything else is exactly the same, so you don't have to rewrite any of those things, all of that. But then 2 over 3 divided by 1 over 3, you're just going to get the 2, because that's all that's left on the numerator. It's just the 2. We can see it as 2 over 1, but that's still just 2. And then what's left here? Well, first of all, we have a minus, and then we have a 1 over 3 and a 1 over 3. We don't have to write that. Pi is there, r cubed is there, and then the only thing we have to write left is tan squared theta over 2. So that is all that we have. And this is the equation we have. Let's just compare it to what they told us. They said that it needs to be equal to, okay, pi r cubed over 3. So they're not leaving that 1 over 3. Okay, so let's just go ahead and do that. You see here by 1 over 3, 1 is just your numerator. This is technically on the numerator, and they're both multiplying. So you can see it as 1 times this numerator of pi r cubed. We will just give you pi r cubed. And then the 3 as a denominator multiplied by the 1 as a denominator is just 3. And so that stays the same, minus tan squared of theta over 2. So theta over 2. And that's what they have. Because if you look at that, it's exactly the same. So there we go. That is the remaining volume after the cone is cut out. Okay, so now we're on the last question, which is 6.3. So 6.3, the last question says, the cone is filled with wax and a wick. Okay, let me get the diagram so that we can illustrate as we go on. Okay, so they say the cone is filled with wax and a wick. So that's this part. We can look at the gray shading as if that's the wax that is filled inside this cone. So wax and a wick. So I'm guessing the wick, I don't really know much about candle making, but I'm guessing the wick is that string that they put inside the candle, you know, that burns when you light it. So the wick is always 1 centimeter below the level of wax, but the wick must not protrude over the level of the flat surface of the hemisphere. Okay, let's just break that up. They said the wick is always 1 centimeter below the level of wax. So let's see it like that. They put the wax inside, and this is it filled up like that. So this is the level of the wax. Let's look at that like that. That's the level of the wax. And they're telling us that the wick, that stick that they're going to put, it must always be, they said, 1 centimeter below the level of wax. So here's the wax. The wick must always be 1 centimeter below. So let's just say we're looking at it as that's the flat surface, right? The wick is always 1 centimeter below it. Okay, so that's where the wick is going to start. That is the wick. Okay. Then they tell us, so really all you can see by them saying that really is that you know that the height of this is that R, right? That wick must just be 1 centimeter below that. Then they continue by telling us that, but the wick must not protrude over the level of the flat surface of the hemisphere. Okay, so with that, they're just saying that this stick, right, that line, that string, it should not go over above the surface of the hemisphere. And I'm already guessing that the hemisphere and this surface, well, they're not the same size anymore, because the thing is that this stick must not be above the hemisphere, and it's always 1 centimeter below the wax. Well, the thing is, if it's already 1 centimeter below the wax, 1 centimeter below, then of course it's not going to go over the flat surface of the hemisphere. So we still have what we had before. This is just 1 centimeters below that. Okay, then they tell us that the radius of the hemisphere r, so now they're giving us a length for that r, okay, for TV, that it's 12 centimeters. So we know this is 12 centimeters. And the angle of the cone is 36 degrees. So this is 36 degrees. We need to determine the volume of the wax that must be put into each candle holder. So how much of wax must be put in? Well, the only thing they told us about this wax being filled is that that wick must be 1 centimeters below that, okay, the wax. So if the wick must be 1 centimeters below the wax, and that wick cannot go past this entire surface, it really just means that whatever this radius is, remember this radius is going from the bottom right to the top to the surface, right? That's the radius. The wick must be 1 centimeters below that radius. So it means that your wick is actually supposed to be 11 centimeters since the radius is 12 centimeters. And they told you that the wax must not go past this, okay, the surface of that. So that's actually where the wax is going to be. If this is 1 centimeters below that, then the wax is going to be a centimeters lower than whatever that entire height is, whatever that radius is, that big R. Okay, so the only difference here now in finding the volume of this is that our volume for our cone, the wax filled in here, is not going to be 12 centimeters now. It's going to be 11 centimeters because that wick is 1 centimeter below that height or the radius. Okay, and they really just want us to find that volume of the wax. Okay, so let's find the volume of the wax. The wax, right, is filled into the cone. So we need the volume of a cone. Remember, we already found the volume of a cone when we were trying to find that remaining part. The volume of this cone, right, in terms of r and that theta, is this. So I'm just going to reuse that as this. It finally gave us this. I'm going to just reuse this again because there's no use of just going to find a new formula when it's going to be exactly the same. So our volume is equal to, and let's just substitute everything that we know here. First of all, we know that theta is 36 degrees. We know as well that r, we have a formula for r, and we actually do know what r is. Our r, right, for the cone, that the wax, not the cone really, the wax, right, since the r here was 12 centimeters, our r is going to be 11 centimeters because of that wick being 11 centimeters high. So in place of r, we're going to put 11. So our answer here is just going to be 1 over 3, and we'll say pi. In place of r cubed, we'll just say 11 all cubed, and then multiply by tan squared of 36 degrees over 2. Okay, let's see what that gives us on our calculator. Okay, and you see the volume we get in decimal, it is 147 points, and I'll round off to 5, okay, so 0.15, and this is volume, so it's in centimeters cubed. And I know it's in centimeters because they told us that this was 12 centimeters. So that is the answer for that question. And that is the last question in the 2 and 3D trigonometry section. And then we move on to Euclidean geometry. Okay, so we're on question 7, Euclidean geometry, and it says CD is a diameter and PC is a tangent to the circle, as you can see at C. And then they tell us that chord DK is produced to P, and they tell us that PT intersects KC at Q. And then they start giving us angles. So angle CDP, so CDP is 40 degrees, DPT is 25 degrees, and we have that TQC is 65 degrees. Okay, so the first question is for us to determine with reasons the size of the following. Okay, so we need to find angle C2. So looking at angle C2, do you remember that they said that CP is a tangent? So the angle between a tangent and a chord, that angle, would be equal to the angle supported by that same chord. So as you can see, CP is going to be equal to 40 degrees. So we can tell them angle C2 actually, sorry, C2 is equal to 40 degrees, and it's because of the tan chord theorem. Okay, so put that down because it may help you in the next questions. Okay, so that's the first question. Moving on to the next question. So they want us to find the size of angle K1. So angle K1 is over there. So let's look at K1. It's at the circumference, but do you see that it's been supported by DC, which they told us was a diameter, or CD, right? They told us that was a diameter. So the angle at the circumference, of course, supported by a diameter is always going to be equal to 90 degrees. So angle K1 is 90 degrees. K1 equals 90 degrees. And the reason you can use there is angle in a semicircle. So you can just say that. Okay, make sure you also put that. I'll just put the symbol for 90 degrees over there. So we have that. Moving on to the next question. Then we need to find angle P1. So angle P1 is this angle over here. How can we find angle P1? Well, I see that P1 is way outside the circle. So we could just use the fact that it's part of triangles. Okay, it's part of this triangle. It's also part of this triangle. But you see, if you use it as part of this bigger triangle, you don't really have angle C1, neither do you have T1, so we can't find it like that. If you use it as part of this triangle, we don't have this angle Q1, but you see that we can find it using angles on a straight line. But this is only for 2 marks, so I'm going to just look for a quicker way to do this. Okay, so you see that you have the exterior angle of 65 degrees here. The exterior angle of a triangle is always equal to the sum of the 2 opposite interior angles. So angle P1 plus 40 degrees will give you 65 degrees. So it means that angle P1 will be found by taking 65 degrees and subtracting it by 40 degrees. Okay, so we'll say angle P1 is equal to 65 minus 40 degrees. And the reason for that is really the exterior angle of a triangle. Okay, so I'm not putting the full reasons because grade 11s, they don't really need to put the full reasons. But in grade 12, for the final paper, I think you have to actually use the full reasons there. So this would mean that angle P1 is equal to 15. Okay, grade 12s, I noticed that I made a mistake here. So angle P1 is actually going to be equal to 25 degrees, not 15, okay? So that now caused a mistake in the next question, which I'm going to correct right now. So angle P1 is equal to 25 degrees, so we'd have to fill that in. That is now 25 degrees, and we of course know our reason for that, the exterior angle of a triangle. Okay, so because that is equal to 25 degrees, the next question 7.2 says, prove with reasons that TC is equal to QC. So let's look at those lines that they're referring to. So they want us to show them that TC is equal to QC. Well, that's like them saying, prove that this is an isosceles triangle. And if these two lines are equal, then the angles opposite their equal sides should also be equal. In other words, they actually just want you to find angle T1. Okay, and it of course will be equal to 65 degrees. So what we can do with that is, let's look at this as a triangle. You see, you could look at this big triangle, but of course to use that triangle, you would need this angle. So, and then you have this angle and you need to find T1. So here's the thing we know about this. Since this is a diameter and this is a tangent, the diameter will pass the center of the circle. So the radius is always perpendicular to the tangent at the point of contact. So because of that, we know this is 90 degrees. Okay, so let's also go ahead and tell them that this angle, let's just call it DCP, that angle is 90 degrees. So tell them that DCP is equal to 90 degrees. That's a P, 90 degrees, because the tangent is perpendicular to the radius. Okay, you can just say tangent perpendicular to radius. And then now that we know that this is 90 degrees, okay, so what we're going to do here is use this full triangle now, okay? So the sum of angles in a triangle give us 180 degrees. So that's angle T1 plus that 90 degrees. So I can just say that we will find angle T1 by saying 180 degrees minus our 90 degrees, minus our 25 degrees, okay? So you see what we did, minus that and minus that. Okay, so that is going to be 180 minus 90 is 90. And 90 minus 25 is your 65 degrees, okay? So that's actually how we get that. So angle T1 is equal to 65 degrees. And this is, of course, because of the sum of angles in a triangle. Okay, so that's that. And because T1 is equal to 65 degrees, this means now that these two angles are equal. Because you have two angles equal in a triangle, it means that you have an isosceles triangle, therefore their two opposite sides are equal. So that concludes that TC, therefore it means that TC is equal to QC. And the reason that you can give them there is, instead of saying angles opposite equal sides are equal, we already had equal angles. So just say sides opposite equal angles. Equal angles are equal. Okay, so there, sides opposite equal angles are equal. And that's how we prove that TC is equal to QC. And that is it for question 7. As you can see, it's a total of 8 marks. Then we move on to question 8. Okay, so we're on question 8, and it says, in the diagram below, the points T, U, and V lie on the circumference of the circle with the center O. So on the answer sheet B, we're just going to use this one, provided, prove the theorem which states that TOV is 2 times the size of TUV. So you need to show that this angle is double the size of that angle. Okay, I have this proof already on my channel, but I'm going to still just do it here for the sake of this question paper. So the first step is to prove this theorem. We are going to draw a line, right, that's going to divide this angle U and the angle O. So the line is really just going to go like that. And that's the line that we're going to have. It's going to divide those angles. But let it be a construction line, so I'll make it dotted. So that's the only construction we need to really make. So you can actually just say construct line UO, and let's just extend it to a point. So I'll just call that P, extend it to P. Okay, and then we can just, because this is we're treating it as if it's the answer sheet B. So let's just go ahead and label these angles. So we can call that angle U1 and angle U2. And we can call that angle O1 and angle O2. So here is how we're going to prove this theorem. Do you see that you have a triangle here, right? Look at this first triangle that we have. And if that is a triangle, it means that angle O1 is the exterior angle of this triangle. And you know that the exterior angle of a triangle is always going to be equal to the sum of the two opposite interior angles. Okay, so we add those two together and they give us angle O1. So what we can say there is that angle O1, tell them that angle O1 is equal to angle T plus angle U1. So angle T plus angle U1. And the reason for this is, of course, the exterior angle of a triangle. Okay, but here's the thing about these angles that we have. Do you notice that OT, right, is a radius? It's going from the center to the circumference. But so is OU. It's also a radius. So those two lines are equal. So we're going to tell them that, but OT is equal to OU because they're equal radii. Now, here's why I'm saying that they're equal, pointing out that they're equal. If they're equal, it means that the angles opposite their equal sides are also equal. So it means that angle U1 is equal to angle T. So we can tell them that therefore this means that angle U1 is equal to angle T because of angles opposite equal sides. So angles opposite equal sides are equal. Okay, so we have that. So since these two are equal, we can actually rewrite this formula. So it means that the formula for O1, right, was equal to angle T plus U1. But since these two are equal, and just remember, they want you to prove that TOV is equal to 2 times the size of TUV. They're focusing on this part, not the T. So what we can do is, in place of angle T here, we can replace that with angle U1 since they are equal. So I'm saying that angle U1 instead of T plus angle U1. And if you simplify that, that is angle O1 being equal to angle U1. Okay, So that's what we have there. Okay, so after we have shown them this, now let's actually look at this part. You see that here we have another triangle. Okay, we have another triangle OUV. And it has an exterior angle as well, which is angle O2. Okay, this is just extended to P, so angle O2. So it would mean that angle O2, being the exterior angle, is equal to angle U2 plus angle V. Okay, so we're going to tell them that. So angle O2 is equal to angle U2 plus angle V. And of course, again, it's because of the exterior angle of a triangle. So after showing them that, do you see that in this triangle again, you have a radius and another radius from the center to the circumference. So they're equal in length. So we're going to tell them that they're equal. Tell them, but we can see that OV is equal to OU. So OV equals OU because they're equal radii. And because they're equal, this will show us that the angles that lie opposite their equal sides are equal. So V is equal to U2. Okay, so angle V is equal to angle U2. So because of angles opposite equal sides are equal. Okay, because they are equal, now we can rewrite this equation for the exterior angle of a triangle. It means that angle O2 is actually equal to, so we have angle U2, and in place of V, we can replace that with U2 since V and U2 are equal. Remember, we're focusing on U2 because it is that angle at the circumference that we're trying to prove in TUV. So because of that, it means that angle O2 is really just equal to 2 angle U2. Okay, so remember what we're trying to prove is this. TOV, right, is equal to 2 times the size of TUV. TOV is made up of angle O1 plus angle O2. When you add them together, they give you that TOV. So we're going to add those angles. So we're saying therefore angle O1 plus angle O2 is equal to, and angle O1 is equal to 2 angle U1. So that's 2 angle U1 plus angle O2 is equal to 2 angle U2. And now you see, let me just actually rewrite that. That's still angle O1 plus angle O2. Do you see that here you have a common factor of 2? So we can take that as a common factor and you're left with angle U1 plus angle U2. And now we need to go ahead and just simplify this. Angle O1 plus angle O2 is that angle TOV. TOV, the addition of those angles give you TOV. So we can replace that with TOV. And it's equal to 2 times the size of angle U1 plus angle U2, which if we look at is the angle TUV. Okay, so it's equal to TUV. And that's how we prove that theorem. Okay, so that is it. It's for 5 marks. It's really a place that you can score marks. And then we move on to the next questions of question 8. So we are finally on 8.2 and it says, in the diagram below, the 2 equal circles, so they emphasize that. So these circles are exactly the same. It's like copy and paste of the same circle. And they tell us the 2 equal circles with centers O and M are drawn. And then chords AB, DM are produced to C. Okay, as you can see, they meet at C. And then they tell us that chord OB is produced to meet AD at F. Okay, so that is produced to meet AD at F. Then they tell us that AB is a tangent to the circle with a center at M, with that center M at B. Okay, so that's a tangent to this circle. And then AD is a tangent at D. So AD is a tangent to this circle at D. Okay, so basically what we can see here is that this circle has 2 tangents. It has this as a tangent, AB being a tangent, and it has AD being a tangent. So the other circle doesn't have a tangent. Okay. Then they also tell us that angle DOB is equal to 2x. So that's the only angle they give you. So in terms of x. The first reason is to provide a reason why DOBM is a rhombus. So this DOBM, why is that a rhombus? And this is for 1 mark, which already raises eyebrows. Okay, so here's why I say this raises eyebrows. Let's speak about how you prove something is a rhombus. You see these shapes, a rectangle, a square, and a rhombus, right? These three shapes. For you to prove that these shapes are actually what they are, square, a rectangle, and a rhombus, for you to prove that, you need to first prove that they are a parallelogram. So that's the one thing. You first have to prove the shape is a parallelogram. Then, for example, you can prove it's a rhombus, or you can prove it's a square or a rectangle. Now, I can't really explain all of that in this video, so I'm going to have to just cut it short. Let me focus on the rhombus. For you to prove that something is a rhombus, you first have to prove that it is a parallelogram. Now, there are about 5 ways for you to prove that it's a parallelogram. The first way is you have to prove that both pairs of opposite sides are parallel. Then it is a parallelogram, okay? The second way to prove that it's a parallelogram is to prove that both pairs of opposite sides are equal. Then the third way to prove that it's a parallelogram is that one pair of opposite sides are both equal and parallel. Then the fourth way to prove that it's a parallelogram is to prove that both pairs of opposite angles are equal. And then there's one more way, okay? The fifth way to prove it's a parallelogram is to prove that the diagonals bisect each other. So here I'm showing you a screen of how you prove a parallelogram. It's one of the most important shapes to prove, because if you can prove something is a parallelogram, you can prove that it is a square, rectangle, or rhombus. For you to prove that a shape is a rhombus, you first have to prove it's a parallelogram, and then either one of these. You have to prove that one pair of adjacent sides are equal, or prove that the diagonals are going to bisect each other at 90 degrees. Now, based on our diagram, the best way we can do this, so the reason I say this raises concerns is because you first have to prove it's a parallelogram, then a rhombus. So this should be at least like 4 marks or 3 marks, not really like 1 mark, but I'm just going to go with what they're trying to hint here. What they're probably assuming, which they didn't mention on top, they're probably assuming that this shape is already a parallelogram. And now we have to additionally prove that it is a rhombus. So what they're assuming is that this shape is already a parallelogram, and now you have to additionally prove that it is a rhombus. So you can use one of the 2 ways that I spoke about, okay? So you can either prove that the diagonals bisect each other, but that's not really a good idea here because we don't even see any diagonals, okay? Or you could prove that one pair of adjacent sides are equal. And I feel like that would be easier in this case. So if I look at this shape and I prove that, let's just go with the easy ones. So if I go with these two, it's not really that nice because you see that OB is part of that triangle and then BM is part of this triangle. So it's easier to just say those two are equal. And the reason I'm saying so is because look at OB and look at OD. They come from the same circle, first of all, and they're both radiuses or radii, okay? So they would be equal because of equal radii. So I can just tell them, okay, first of all, we know that OB is equal to OD because of equal radii. You could just say radii. I'll put that in black. And then you can also just now conclude that DOBM is a rhombus because a pair of adjacent sides are equal. Okay, and that is proven. So that's probably what they want you to do there. Now, because we called it a rhombus, I'm going to apply everything I know about a rhombus to this shape. So a rhombus has all the sides being equal. So I'm already going to put that down so I don't forget, since we have now proven it's a rhombus or given them a reason that it is a rhombus, right? And it also has a pair of opposite sides being parallel, meaning OB is parallel to DM and OD is parallel to BM. Okay, so that's another thing that we have. And of course, the opposite angles would be equal because it's a rhombus. Okay, so I'm also going to put that there. That is that. Remember, one pair of opposite angles must be equal. So B2 is already equal to D1. And then it means that angle, well, I can't really call that O. So DOB would be equal to angle M1. These are things that you need to do. Once you prove a shape is something, then you know that all the properties of that shape is going to be applied to it because it is that particular shape. In this case, a rhombus. Okay, so that is the first question, and we've filled in a lot. Moving on to the next question. The next question says, provide the geometric reason why each of the following angles are equal to x. That is a very nice question because they're not asking you to find angles that are equal to x. They're giving you the angles and saying, hey, this is equal to x. Just tell us why. Okay, so let's look at that. Angle A. Why is A equal to x? Okay, I think that one is quite simple. You can see this circle here, right? And angle, well, 2x is the angle at the center supported by the arc BD. And you see that angle A over there is the angle at the circumference, also supported by arc BD. So the angle at the center is twice the angle at the circumference, supported by the same arc or chord. In this case, it's an arc. So we have A being equal to x as well, since this is 2x. So it must be half that size. Okay, so that's the first one. I can just tell them angle A is equal to x because of angle at the center being twice the angle at the circumference. Okay, so that is that question. Moving on to the next question. So the next question is angle M2. So they're telling us angle M2 is equal to x. We just need to tell them why. So I'm just going to put these in red. Angle M2. Why would this be equal to x? Why exactly is that? Well, do you see here? Look at this, A, B, M, D, right? In this circle, those points are on the edges or on the circumference, right, of the circle. So because of that, that makes that a cyclic quadrilateral. And if it is a cyclic quadrilateral, the reason M2 should be equal to x is because the exterior angle, do you see that this line extends? So this is an exterior angle. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So that's the reason why. Okay, so I can tell them that it's equal to A, and of course A is equal to x. So we can just tell them this is angle M2 is equal to A, and of course A is equal to x because of the exterior angle of a cyclic quadrilateral. Now, honestly, you don't even have to do these. You just have to give them the reason because that's all they're asking for. They just said, give us reasons. So technically, all of this I'm doing is just like extra work. I don't have to write that. They just said give reasons. So I'm just going to put the reasons only for those being equal. The next question, C, is we need to show that angle D1 is equal to x. Or give them reasons why, really. Okay, so let's look at angle D1. You see, as I'm going, I'm writing everything down because it's very important to do that. Why is angle D1 equal to x? Well, remember that, okay, I can see here. Do you remember that the reason this would be equal to x is because, do you see that we said these lines are parallel, right? These lines are parallel because this is a rhombus. So do you see that you have corresponding angles? And we don't even have to tell them the lines are parallel. We proved this is a rhombus, or we gave them a reason it's a rhombus. So they know now the lines are parallel. So you can just tell them that angle D1, well, you don't have to say that. Angle D1 is equal to x because of corresponding angles on parallel lines are equal. So that's the reason I'll have there. Okay, moving on to the next question. The next question, D, is angle B2. So we need to show them or give them a reason why B2 would be equal to x. Okay, so this is already x. Why is B2? Okay, you remember what we said about that? This is a rhombus, right? And in a rhombus, the opposite angles of a rhombus are always going to be equal. So that's why that would be equal to x. Or you could have also looked at it like this. Do you see that because of the parallel lines, you have alternate angles? So I think alternate angles is easier to write. So let's just go with that instead. Okay, so we can say alternate angles on parallel lines are equal. So that's the reason that is equal to x. Okay, and we finally move on to 8.2.3. The next question, 8.2.3, says prove with reasons that angle D2 is equal to angle C. Let's go look at those angles. So we need to show them that angle D2 is equal to angle C. So you look at C and like, C is outside the circle. It's not even, it doesn't have anything to do with the circle. Let's just look at this. It's for 4 marks. So there's more steps involved here. Since it's for 4 marks, we're just going to have to lead up to that. So it's probably a situation maybe that angle D2 is equal to something and that's equal to something and then eventually is equal to angle C. Okay, so let's look at that and see how can angle D2 be equal to C. Now, the good thing about this is you can start from anywhere. You can start from D2 if you want, or you can start from C. So I can show them that angle C eventually is equal to angle D2, or that angle D2, you know, when we move around, gets equal to angle C. Okay, so first of all, I'm noticing something here. Do you see that I'm focusing on D2 and I'm just focusing on trying to find out what exactly D2 is? So I see that this circle that has a center M, that this center, right, we have a line from the center to AD, and AD is a tangent to the circle. Because AD is a tangent to the circle, you know that the radius is always perpendicular to the tangent at the point of contact. So what we can actually say about D2, I can find an expression for D2. I will not really find D2, but it's an expression. Since I know this is perpendicular, then it means that to find angle D2, you say angle D1 plus angle D2, and that will give you 90 degrees, right? Because that is perpendicular to the tangent. So we can do that first. And then tell them, of course, that because of the tangent being perpendicular to the radius, then you can say that angle D1 is X, and then D2 is just D2 is equal to 90, and then leave D2 as the subject. So that's 90 degrees minus X. So that's what we have for D2. So all we have to do here is, if we found that this is 90 degrees minus X, if we can find that C is also 90 degrees minus X, then our problem is solved. Then I can already see how that is going to work. Do you see here? Look at, we have a big triangle. That's 90 degrees, that's X. Okay, so this one was very simple. So I'm just going to write down what we have now. So this is perpendicular. Let me just put that down here. Okay, guys, so this is what I wrote, right? Just exactly what we had before. But now I just have the reason. And then to find angle C, you see that we can use that big triangle that we have there. So angles in a triangle always give you 180 degrees. So we're going to say X plus angle C2 plus the 90 degrees that we have. And it's because of the sum of interior angles in a triangle. Okay, because the sum of angles in a triangle, then you see that you can take all of these over. So angle C2 is equal to 180 degrees minus 90 degrees minus X. And so therefore angle C2 is equal to 180 minus 90 is 90 degrees and then minus X. You see that they're both equal to the same thing. So that therefore means that angle D2 is equal to angle, why am I calling this C2? C is equal to angle C. There we go. And that's how we prove that. Okay, very simple. And then we move on to the next question. Just don't forget to call that 90 degrees minus X. It may help you with the next question. Okay, next question for real now. The last question, prove with reasons that AB is equal to BC. Okay, so for 4 marks, let's go ahead and see. Why would AB, this line, be equal to BC? Let's see. How can we actually prove that here? Yeah, it's always the last question that is like that. Okay, I'm starting to see something here, but now I'm actually surprised that they put it in a grade 11 paper, because it's something that was taught in grade 10, but then, you know, it shows up more in grade 12. And that is the midpoint theorem. So here's the thing about it. Let me speak about what the midpoint theorem says so that you can just remember how it works. So the midpoint theorem has to do with a triangle. If you have a triangle, right, and you have one line being parallel to one side of the triangle, and they tell you that these two sides are equal to each other. Let's just name this triangle. Let's call this ABC, and this is DE, okay? So if you have AD being equal to DB and DE being parallel to BC, what you can conclude is this. Let me actually just put it like this. You will notice that in Euclid is all about you be given certain facts and then you have to prove certain things using those facts. So there's always a given and a conclusion. What did they give you and what do you conclude from that? What you've been given here is what I said, where I said that DE is first of all parallel to BC, and they also told you that AD is equal to DB. This is the midpoint theorem. What you conclude from that is that AE will therefore be equal to EC, and BC, see this big line, it's double the size of this line DE. Those are the two things you conclude. And this is the midpoint theorem. Okay. So this is taught in grade 10. It's used more in grade 12 though. But this now shows that you need to really study everything. Okay, so just to show you that this is actually the theorem being used there, look at what we have here. So remember we already showed them that this shape is a rhombus, okay? Since it's a rhombus, we know that this line is parallel to that line. So we already have that, okay? It's parallel to this whole line, of course, because this is the same line being extended. And then we would have to have two sides, right, being equal to each other. And I'm showing you that it's actually this side and this side. And here's the reason. I can't just assume things. I'll show you why these two sides are actually equal. First of all, you have parallel lines, right? Because you have parallel lines, it would mean that this angle 90 degrees, if you draw corresponding angles upside down, if this is 90 degrees, this must also be 90 degrees. So you already have a 90-degree angle there. Let's actually put that down so we don't forget. So what I'm saying is that angle F2 must be equal to this angle, let's call it ADC, which is 90 degrees, okay? And it's because of corresponding angles. Okay, so that's the first thing we're going to do. We'll tell them that angle F2 is equal to angle ADC, which is of course equal to 90 degrees. F2 is actually equal to 90 degrees because of corresponding angles. Okay, and now that we've shown them that that is equal to 90 degrees, look at what we can use here. Because this is equal to 90 degrees, another thing we can use on this is the fact that, do you see the circle which has the center at O? AD is a chord and OF is the line from the center of the circle perpendicular to that chord. The line from the center of the circle perpendicular to the chord does what to the chord? It bisects the chord. So that makes this line AF equal to the line FD. Okay, so that's another thing we have to tell them now. Okay, so let's go ahead and tell them AF is equal to FD and give them the reason for that. So we're saying that AF is equal to FD because of line from the center of the circle perpendicular to the chord bisects the chord. Okay, and now that we have that, remember, we're just trying to prove to them that those two lines are equal. So here's the thing about that. Those two lines are equal because of the midpoint theorem. See, we have the midpoint theorem here. We know that this line is parallel to this line because that shape is a rhombus. And we know now that these two lines are equal. That is exactly the midpoint theorem. So because we have that, we can already conclude. We don't have to tell them what is given. We can already see what's given. We can conclude that AB is therefore equal to BC, and the reason is because of the midpoint theorem. So therefore AB is equal to BC because of the midpoint theorem. I'm sure you guys have a longer one in grade 12. You just say midpoint theorem, it's fine. They understand what you mean. I'm just going to leave it as midpoint theorem. Okay, so that is the last question for this paper. So you see that it had a lot of things that you should remember from grade 10, mostly grade 11 stuff really. But that one thing, the midpoint theorem, you have to remember from grade 10. So I feel like the only part that took a little longer to explain was like trigonometry, but that's just because the graphs can be, you know how the graphs are. So I'm trying to make sure that you guys understand. I hope it's also just not too long. I don't want to be like trying to make the videos exactly the time as the paper is, because if I was doing the paper by myself, I wouldn't have to explain certain things. I'll just work through them. So with explaining, it's a little more complex. Just let me know if that's okay. And all the best for anybody who has not written paper 2 yet. I really try to just do a recent paper just so that it can really help you guys. All the best for your exams, and I hope you have a good holiday. And I will see you guys in the future videos. Bye for now.